Hello and welcome to the next edition of the Hack the Planet podcast. And we have a historic episode today. We have the world's first antipodal Golang malware developer conference. We're going from one end of the planet to the other, which is what I've been told antipodal means. But if someone's playing a trick on me, for the record, I don't really know what that word means. So I am very, very excited by the roster today. So just to give, I know we don't usually up-level anything for our listeners, but to give you guys some context, I've been doing a lot of sort of, personal project development over the past few years, and when you get interested in more and more narrow topics, you find yourself in more and more narrow chat rooms, and you meet people from all over the planet, literally, who are into the same narrow topics as you. And for my personal interest, which is Golang malware, is one of them. We're joined today by two of the random people I've met on the internet over the past couple of years that I've done the most project development with. So what's interesting about this conversation is that we have not actually talked in person before this call. I think I talked to one of these guys for like 5 minutes a year and a half ago, very, very briefly. So we've just entirely been communicating through chat and pull requests for the most part, or like code samples. So this is going to be, I have no idea where this is going to go. This is going to be a very interesting conversation for one reason or another. If you're not interested in the psychological, social science angle on this, what we're mainly going to be talking about is Golang-based offensive projects, libraries, utilities, how to use Golang for red teaming. Without further ado, although that was a lot of ado, I'll admit, I'd like to introduce our guests today. Joining us from all the way in Perth, Australia, the developer of bananaphone and goWMIexec and something called Secret Stump I'm not familiar with yet, is C-Sto, who we could also call Cam, but I'll probably call C-Sto because it's fun to say. You say hello?
Hello. G'day, I should say.
How's Perth?
Cold, actually.
Really?
Yeah. I don't like it. It's below 20 degrees Celsius.
So that's like February here, so it's like kind of late stage winter?
Yeah, coming out of winter. It's like a drizzly day, I guess. But yeah, I don't like winter, so I have a low tolerance.
Well, it's just getting a point of reference, so now we'll go to the other side of the planet. We have someone who helped me a lot with RatNet development, and also worked on the Binject project, and also developed a really interesting Golang project I'd like to talk more about called Pandora's Box, and is currently working on the Golang obfuscator garble. We have capnspacehook, or Andrew. Hey, Andrew. And so where are you calling in from?
I'm calling in from the south. I'm calling in from Georgia, actually, of the United States.
So now we worked out what the exact opposite of Perth was, and wasn't it like Virginia or something?
Yeah, I think so.
Yeah, so that's close enough.
I just came from Virginia, actually. Was going to college there, so I just moved to Georgia. So
what's the weather like for you right now?
Well, right now it's 2000 or 8 p.m. and I imagine it's around like 70 degrees or 80. I don't know. It's pretty warm down here, but I like it warm.
Oh man, sorry, it's just kind of tripping me out. Having a simultaneous chat with people on the exact opposite end of the planet. Anyway, finally, last but not least, we're joined by Dan, another Golang malware developer and contributor to the Binject project. Say hello, Dan.
What up?
So, I wanted to start out with sort of asking, the one thing that we all kind of have in common is our shared interest in writing malware in Go, specifically the programming language. So for me, I kind of know how I ended up on this path, but I'm sort of curious why, first of all, why malware? And then why Go? I'm most curious about, oh yeah, let's go with Dan.
I could just jump on this really quick because previously I was writing a lot of my malware in PowerShell, and then people came out with like that PowerShell script block logging, and that got really popular. And we also had a lot of our malware in Bash, so we had like these two like desperate languages that we were writing our stuff in. And then when we saw Go, we were like, oh man, cross-platform, we can compile native executables. You know, they're not going to get this logging transcript of all of our crap. So I was really convinced like to do the move, and then once I started writing it, it was like open and shut story. You know what I mean? Like it's such a nice language. I think once you get into it, it kind of sells itself.
If your brain likes it, you write code faster in Go than any other language, and my brain likes it anyway. But C-Sto, what about you? Why malware? Why Go?
Why Mel? So I'm a pen tester. I'm a dirty consultant. So I have to write gross things pretty regularly. But actually, before I became a pen tester, I was writing Go because I started liking it mostly because I did like a unit at university that was meant to teach us like how programming languages worked. I can't remember the name of the unit, but it was like sort of started going into like writing your own programming language and linters and all that sort of stuff. And the person that was taking the unit just didn't give a shit about any of it. So I decided that I wanted to use the unit to like find a language that like really gelled with me, so that I could like go through and like scientifically work out what I liked about a language. And Go was that language, like the whole like all of the ethos behind it, all of the design in it just sort of gelled with me. I like the fact that you can like write it and then write it once and then it runs everywhere. The fact that it like statically compiles everything in is like really good, because you don't have to deal with all the shitty DLLs like you do in C and C# and worry about different runtimes and all that sort of stuff. But yeah.
So you actually got into Go before getting into pen testing.
Yeah.
Which is,
yeah.
you might be the only one. But we'll we can circle back to that. So Andrew, why, same question, why malware, why Go?
So I guess as the definite, I don't know, youngest person here, I have a different story. I went to college, just graduated computer science, and I definitely wanted to focus on cybersecurity aspects and specifically offensive stuff, because I don't know, as a high schooler, I just thought hacking was just the cool stuff. I just like, I didn't know anything, like I didn't have any like real experience or anything, but I just went there and I'm like, I just want to learn everything I can. And after I learned to program through some university classes and just, started writing some of my own projects and getting better, started to do a little bit of defensive stuff, but then came across GScript actually when it was released at, can't remember which DEF CON, but I thought that this was the coolest thing, and it is such a cool thing. Basically, and mixing two languages, being able to like write something in JavaScript and, parsing that and creating a Go executable that bundles a whole bunch of different things, and the logic is determined by just a JavaScript file. Personally, I hate JavaScript, but just the idea of what they were doing was super cool, and I was just like, that blew my mind. So I made a few PRs to it, I think, and then I just started falling in love with the language, just the simplicity, everything. Just because I was doing a lot in C++, because that's what my university was taught me in, and so I tended to over-engineer everything. And then I came to Go, and it's like, hey, there's 25 keywords, all this crazy stuff, it doesn't exist. I'm like, this is refreshing, and I've stayed.
For me, Go definitely fills the niche that C++ would fill, right? Like when you need something to run on embedded, when you're doing kernel code, it basically has to be in C. before I get angry, letters, yes, maybe someday in Rust, but it basically has to be in C, right? But then C++ is for everything where it can just be a giant mess and it has to include the kitchen sink and nobody cares about binary size for the most part, right? And then so I'd done a lot of programming in a lot of different languages, and I had audited C++ to the point that I couldn't and I had some jobs writing C++, but it was like UI stuff way back, and it got to the point where I just like couldn't bear to look at C++ anymore.
I think that's a fair statement to anyone who's developed in C++.
Oh, and that's Max is joining us.
Hey, sorry.
Yeah, no worries. So one thing I forgot to mention in the intro also is that Dan was a developer on GScript. So Dan, do you remember what DEF CON that was?
Oof. Oof.
Do you remember what DEF CON it is now?
No.
Yeah, I mean,
it's a problem.
26. I think.
Is it only
26?
That can't be right.
I just remember that that DEF CON can drink now. That's all I remember.
That was a while ago. That was
Yeah,
in
it was.
Rio. That was in the way back.
DEF
All
CON
right,
can rent a car now.
Anyway, so GScript is another Golang offensive project of note. It involves embedding. It embeds a JavaScript interpreter that lets you script the dropper stage of malware. So to review just for myself and maybe also some of the listeners, there's this like concept of a malware lifecycle. So people sort of talk about the malware lifecycle. It's kind of like the OSI 7-layer model of networking, though people debate which number step is which or whatever. But more or less, there's an initial vector or exploit, and then there's usually a dropper or a first stage. There's like a first stage thing that sometimes is called a dropper that goes out and pulls down other modules or unpacks, decrypts other modules, and then like fires up a bunch of other modules that sort of do the other stages. And then there can be some stuff where it phones home to a command and control server or C2 server for additional instructions, or it could exfiltrate data. Some of the other stages are usually like privilege escalation, recon, gathering information about the network or the host, or spreading. I
was gonna say if it's like just a worm, it'll just move laterally or something dumb.
Yeah, and not every piece of malware necessarily does all of these things, and not all of these things are always automated. So I think in our world, we mostly develop these things for work, for work projects or for CCDC. Which is Dan. Who's done CCDC?
Yeah. So it's the Collegiate Cyber Defense Competition, which is like a defenders competition, but really just like attack defense competitions, right? Where you have like two people that are fighting over a network for a short period of time. I think it's a good simulation of like real defending.
But I think I've had people, you get a lot of people on the internet who are like, how do I hack? Or they're like, oh, how do I write malware? And sometimes I try and like legitimately answer the question. It's a little bit hard to define what malware actually is. It's just sort of like regular code, and code is sort of absent of intention. But putting in this kind of framework where sort of what each component is for in this sort of process is sort of helpful in kind of thinking about it. And the only reason I wanted to bring that up is because I want to start going into some of these specific projects, and because there are projects in Golang for all different parts of the life cycle, although I haven't seen as many actual exploits written in Go, because those tend to be like shell code or command injection or something like that. So we've definitely seen a lot of Golang C2s. Including Sliver and some developed by people on the call. And we've seen a fair number of like implants and sort of modules for implants that do various things. But there's another aspect to it where there's also like crypting the payload or just obfuscating things. trying to strip out anything that can be signature checked. And there's some stuff in that space. And so I think the coolest thing that I've seen recently is definitely bananaphone.
What is
and
that?
yeah, well, so we'd previously talked about the Hell's Gate attack, but I'm gonna hand it over to C-Sto. So what can you tell us sort of how you kind of what bananaphone is, what purpose it serves, and kind of how you came up with it? How you came up with it?
Yeah. So, bananaphone is not, or bananaphone if you're American, I guess, is nothing new. It's pretty much just a Go version of Hell's Gate, and Hell's Gate, as I understand it, is playing on the Heaven's Gate sort of mechanism in Windows, where 32-bit processes sort of go through into 64-bit land, but the Hell's Gate stuff doesn't really have much to do with that. It just uses the same sort of wrappers or uses the same, I guess, thin wrappers that that trampoline does. So you can directly call kernel functions, functions that go into kernel land directly, as opposed to going through like user land functions. Probably a terrible way of explaining it, but
well, so basically, there are these thin wrappers in NTDLL for Windows kernel functions, and something to do with the 32-bit 64 subsystem crap. For whatever reason, they make these thin wrappers that have the actual system ID, or the syscall ID is in a known location in the wrapper. So what you do is you pick the syscall ID out and then set up your own stack frame, and then just call directly into the kernel call, I guess it's not directly into the kernel, but it's directly into the call that the wrapper was wrapping.
Yes, yeah, it's a bit weird to explain, but yeah, it's the like real short version is that you move the right number into EAX and then syscall, and then it does the thing.
It reads the syscall ID out of the EAX register, so you basically just need to tell it which syscall you want to call, and then set up a stack frame. But you took it, and that's the standard Hell's Gate attack. But bananaphone kind of went a bit past that. So it also implements the standard part of Hell's Gate, where you locate the PEB, and walk the PEB, and you find all of the other libraries that are currently loaded and mapped into your process's memory space, and then you can walk all of those and call things, directly. Also, all of the important calls are wrapped in NTDLL, like virtual alloc and create thread. So in the bananaphone examples folder, there's a piece of code that can run calc.
Yes.
Right.
Yes.
So you have the run calc example, which executes a payload basically without. And so, why are you doing this? Like, what's the advantage?
So, if you're using all of the functions that in NTDLL normally, the way that it sort of works is that your program calls the functions in the DLL that's loaded in memory, and antivirus and EDR and all of that put hooks in your in there basically. So if you're calling these directly using the syscall IDs, you never sort of jump into that memory space where the EDR or AV is. So you just completely bypass all of that, which is very useful if you are writing code that does bad stuff.
So this is for EDR evasion. So there are EDRs that actually modify NTDLL in memory, and they insert code into these wrappers and modify the wrappers so that they don't just have so that if you call through the wrapper, that gets like logged and registered by the EDR. And in in some cases, well, so can you tell me a little bit about auto mode and bananaphone? Because
sure.
I want to talk about so far the functionality we've described is more or less what the traditional Hell's Gate attack did, but then bananaphone has a couple extra features, and one of them is the auto mode, which is really interesting. And the other thing I wanted to ask about is the make win syscall wrapper.
Okay, so there's two main modes of getting those syscall IDs, because you need to be able to get those syscall IDs to call the function that you want. The most sort of sane, or the sneakiest way that you can do it if it works, is to, like you said, walk the PEB and then see what's in memory. Doing that, you don't need to make any other system calls. It's all just like shellcode, I guess, that will do all of this. It won't make any API calls in Windows that would be able to be detected by anything really, to be able to get those syscall IDs. So if you're doing it all in memory, you want to get the PEB location, and then from the PEB you can get the start address of the NTDLL image in memory, and then using the debug PE thing that I think you actually built, Ben.
Actually, everyone else on the call helped with that. So Dan, Andrew, and me. That was our project.
Yeah. So using that extremely handy library, you can parse the PE that's in memory to find all of the exported functions. Once you got the address of the function that you want to call, you can, they're all in a really standard structure. So it's like 6 bytes in is where the syscall ID is. So in memory mode, that's what you do, and it's all like I can't think of any way that AV or EDR would be able to detect it or hook it at all. The problem with that is that if EDR is hooking those functions, then the offset to that syscall ID is going to be wrong, or may not exist, or it'll be put somewhere else, basically.
Like the syscall ID is not just sitting there. Instead, they put a jump to their custom hook function that does some magic and then comes back with EAX set to whatever the syscall should have been.
Yeah, exactly.
But you can't just scrape it from a known location anymore.
No, and it could be anywhere. Like trying to like jump into their sort of code that does all of that and then work it out from there is sort of a lost cause, I think. So if you're in auto mode, then if that fails, what you can do is you can then load the NTDLL from disk. And I think that the way that most of the other Hell's Gate implementations do it is that they do a map image, map file to image or something like that, so that they put it in memory and do that. But using the PE or the debug library, you can just load it from disk and then parse it on disk and do exactly the same thing. The only thing with the on disk version is obviously you've got all the API calls that you need to do to get the file. So that's slightly more noisy, but no more noisy than reading files.
I just remembered the one thing that was like super interesting about this project, and I would recommend anyone who's at all interested in Go malware development to check out the source code for bananaphone on GitHub. We'll definitely have a link in the comments. But the most interesting thing about this was your use of Go assembly. Because
that was an experience. Yeah.
I didn't even know Go assembly was a thing. And then it's not even like ATT syntax assembly or like Intel syntax assembly. They made up their own, weird Go assembly, and there's all these
Has this always been a feature of Go?
Yeah. What is the deal with where did this come from?
It's always been. So this is like the. I think it's always been a feature of Go. I know it's been around since like 1.6 or thereabouts. And it's never been well documented though.
The only way I've ever gotten anything working in Go assembly is by copying your layout from bananaphone and then just editing things.
Yeah,
'Cause
yeah. So
there
it's like a gross Plan 9 assembly thing that, but it's not quite
Yeah.
Plan 9, and it's not great to write in. And obviously, it's like different from 64-bit and 32-bit. So,
Yeah. So how did you figure that out?
so the starting point for that was I remember reading a blog post. I think it was a Dave Cheney blog post about optimizing functions in by using assembly that you define. And I thought that's kind of interesting because it looks a lot like it looks just like assembly, but it's not quite assembly. So what are the odds that this compiles to something that roughly translates to something that I can debug nicely? And it does actually compile pretty closely to the bytecode that gets put in is pretty much exactly what you want. The compiler does optimize things for you. So, for example, I spent probably about 6 hours trying to work out why something wasn't working, and it was because the compiler had just like removed a whole chunk of my assembly because it didn't think that it was going to be used, which was very frustrating because I was trying to manually jump to that in the debugger. So it was never actually used. The compiler was right. It was just silently removing it, which is a bit shit. But I remembered seeing something, a post about that, and then sort of came to the conclusion that pretty much everything in Go is built in Go at the moment. Like the whole tool chain is all Go, so Go compiles Go into all of that. So I just did the sort of hacker thing of like, well, how does that actually work? And sort of going through all of the functions and trying to work out how syscalls worked in Windows. Because there's you can call functions in DLLs using the syscall lib in Go, and I figured that there must be a way of like surely that was defined somewhere, and eventually it led me down to this kind of hard to understand fork where I had to make a few guesses, and then ended up in a function that did basically what I wanted. And what that was turning a Go function, which passes all of the arguments and return values in the stack, into a native Windows fast call. What was it called? AB. Yeah.
It's for application binary interface or whatever. It basically is a fancy way of saying which registers get used to pass arguments into functions. So Windows 64 convention is like 9, 10, C and D or something. And then the Plan 9 ABI is all arguments are on the stack, no registers at all. So that's just how weird Plan 9 is.
Yeah.
I want to say that's also Solaris.
Yeah. It's also the ABI that Go uses internally. Because everything Go is basically like the Plan 9 team redoes C++. That's kind of like what Go is.
So one thing to note, though, I just saw a proposal, I think 2 days ago, about making the Go calling convention register based for added performance. So I think they're targeting that for like 1.16.
That's some like Microsoft intern. They're always trying to like change the order of the like which registers get used. It's like, oh, it's slightly faster if you use a different register. It's like, I don't think that's the real reason, man.
Well, right now, like you guys mentioned, I think the Go like calling convention or ABI is like all stack based, and they're trying to make it actually use some registers or be register based.
That was a conscious decision in the beginning, though, and I think it's going to turn into a mailing list holy war.
We'll see.
Yeah.
Generics again. Generics argument.
Yeah, exactly. I don't really have a horse in that race at all. But when you were looking at the make win syscall stuff, just to wrap up on bananaphone, the really cool thing about bananaphone is you actually made it so I can define a direct Windows system call using the same kind of syntax that you use with the regular Go make WinSysCall, make sysWinCall, make WinSysCall script. That's just it's really, really slick. So I actually have written some examples with that where we took your calc, your pop calc example, and then we have it just like download Mimikatz from the network, and then we use GoDonut to convert that into the executable Mimikatz into a shellcode that we can load, which is also a bit obfuscated because Donut kind of does that. So the moment that it actually hits memory, it doesn't look like Mimikatz, and it never touches disk. And so we download it, run GoDonut on it to make it into a payload, and then basically run it with direct syscalls through bananaphone, and it executes just fine. It even shows up with the Donut update. It even shows up in console mode and everything, and you can use it, right? So this is this is not checked in yet, but I think this is going to be this is going to end up as the next version of goWMIexec. But it's just 2 pages of code, and you can run this program, and it basically will download Mimikatz from wherever you are in the world, like scramble it up in a totally unnecessary way, and then execute it directly in memory. Since EDRs for the most part can't scan all of memory regularly, we're bypassing all of these detection points, using the direct syscalls, and also just having it be obfuscated by Donut like when it hits memory, which is pretty cool, I think. But
I did want to mention something really quick, just while we were still on Go assembly before we get too far from it. There's a really cool library called AVO, which you can write automated Go assembly.
Really? Tell me more about that. Everyone's waving their hands, so I haven't heard about AVO.
Yeah, I'll let one of these guys take it. But like, this guy Mike McLaughlin wrote it. They use it for basically tweaking high performance Go on like big services. Like I know they used it at Uber for a while.
So does it like? How do you use it? Like, does it automatically kind of detect things that need to be optimized, or do you use it with a profiler, or what kind of creature is it?
You write a high level language, and then it auto generates the like ASM or assembly for you. So it's ideally easier to understand and write and like review. That's my understanding of it.
Oh, so it's another language that you write in it, and it generates Go assembly?
Yeah.
Oh, that's weird. So it's like another. It's like when they make like Scala or Clojure or whatever over the JVM, but it's not Java, but it generates JVM bytecode.
Yeah, the idea is it's easier to read, and it generates high performance bytecode. You know what I mean? High performance assembly.
It's super.
Is it maybe like a closer 1-to-1 match with the assembly as well than the Go code itself?
It may be. I'm not sure. I haven't actually like messed with it too much.
That's fair.
I'll have to check that out. That sounds. I'm usually more concerned with running things in as fucked up a way as possible, rather than trying to make them efficient. I'm usually trying to like obfuscate everything like way too much. Well, just to change gears and switch to the other side of the planet. Another sort of hot topic in Go malware recently has been obfuscation and stripping symbols. So there are some downsides. We talked to Go up a lot in the beginning, but there are some downsides to writing malware with Go, especially writing implants. The biggest unsolved problem at the moment, so Go 1.15 just came out, and everyone was sort of like, there's been a persistent rumor that the size of the Go runtime would be decreased at some point, but not as of 1.15, not yet. But the main problem with using Go to write implants is, although it does statically compile all of your code down to one binary, and it has a built-in, cross compiler, so it can generate a binary that'll run on anything, right? But when it does that, it includes a 1.2 megabyte approximately blob, which is the Go runtime. And there are some, and the Go runtime is included in its entirety in every Go binary, whether or not the actual features in it are in use by that code. And that is the thing that the static compilation was supposed to be avoiding in the first place. So this is like a kind of conceptual what the fuck for a lot of Go developers. And it also means that if you end up writing a C2 implant delivery system that delivers a lot of Go implants, it means that your implant modules are 1.2 megabytes minimum, which seems large to some people, but in practice doesn't really matter. And then a lot of the reverse and then you worried about, the blue team reverse engineering your shit. There's not as much experience in reverse engineering Go binaries out in the world as some other things. Like definitely .NET is easy, Java is easy. Everybody's been using sort of IDA on regular Windows stuff. But to some extent, the Go runtime sort of helps you out because there's this, big mess of stuff and people aren't sure how to pick it apart. But the other problem is that they include a lot of strings and other information in the Go binary, like metadata in order to help the reflection system work and stuff like that. And there's really sort of a lot of leftover cruft in Go to that needs to be stripped out. And since the Go developers are definitely not comfortable with how popular Go has become with offensive tools developers, they're not motivated to help us write better metadata removal stuff. So there was an earlier project called goWMIexec, which was an attempt to partially solve this problem, and there's a new project called Garble, which I can't speak to too much myself, but I'm gonna hand this over to Andrew. Clear the other side of the planet now. If you could tell us sort of, tell us a little bit about what kind of metadata, what kind of information is leaking in a Go binary, and sort of how goWMIexec tried to deal with it, what goWMIexec deals with well, but then like why we need garble and what does garble do?
Yeah, sure. Like you mentioned, there is a ton of metadata in Go binaries, and you kind of mentioned that the Go runtime kind of helps you out in a sense that if you just look at it like in a disassembler, like IDA or something, it just looks like a big mess of stuff, and it really does. But as soon as you get some kind of understanding of just how to find certain functions, and just how to look at things with the Go runtime, like in the Go way, it's pretty easy to figure out what a Go binary is doing because there are function names in a Go binary, like all the function names that you ever called, and potentially some function names that will never be called are in there. There are import paths. There are global variable names, not constant names, so not global constants. I was actually surprised to find that out the other day. There are line numbers for all the functions that you're called in there. There are file names of all the files compiled in there. I'm trying to think of anything else. Obviously, strings like any binary. I think that's most of it. For structs, there are like the fields of structs. The names of those are also in there. There's a lot. Methods, it's a lot. So there is actually a tool called Redress on GitHub. We should probably link to that. That is the only main tool I know of that deals with kind of helping our first engineers with Go. It basically kind of takes apart Go binary and redresses it in a sense, and shows you all the file names, builds a source code tree, shows you all the packages used, shows you all the types used. Type information is also in a Go binary. Shows you the Go version it was compiled with. It's pretty cool. So, as Ben mentioned, there is a program called goOffuscate or goOffuscate. I don't know how to say it exactly, but
goWMIexec.
It's probably better. goOffuscate. Okay. And that was pre-Go modules. So that was basically working off of the whole Go path thing. So what goBFuscate did, it kind of took a brute force approach to obfuscation. It basically took your source code that you fed it, and it walked recursively all of your imports, and it directly copied those files from disk into a new like Go path, like all of them. So this can be, this is the law, recursively all depending, copying dependencies and imports, and then it would go and rename symbols on everything. So it's incredibly slow because it copies your entire, almost like a big section of your Go path over somewhere on disk, and then it'll say, oh, I want to rename foo.bar, and it's like, well, foo.bar is called in 15 packages. Well, it has to walk every package, every function call, everything, and search for a call to foo.bar and obfuscate it the same way. And it's Sliver uses it right now, that C2 framework I talked about. What was that?
Yeah, we'll definitely have to circle back around and talk about Sliver some more. I was just gonna say, I didn't do so well in this class in school, but I think that's like NP hard, right? That's definitely that's a non-polynomial algorithm anyway. Like,
it's not optimal. Anyway, he says it.
It's also worth mentioning too. It's not native Go. It uses C-Go, I think, for some part of it. Is that goBFuscate or a different? Maybe not. Maybe I'm just thinking Sliver in general.
Yeah, I know Sliver can use some C-Go, but goBFuscate, it has some code to work with C-Go, but as far as I know, it doesn't use any C-Go. Yeah, so Sliver uses goBFuscate to obfuscate its binaries, and build times can take anywhere from 10 to 15 to 20 minutes. Build times including obfuscation. So, yeah, goBFuscate, another thing is it's not super stable. I've tested out a couple times, and I've never really gotten it to work. The guys over at Sliver actually have a heavily modified version of goBFuscate that they use. And that's the only way they've gotten it to work. So it's not really a it's not really a tool I recommend. So Garble is a project that has a similar aim to basically just obfuscate Go malware that I came across recently. And believe it or not, it is actually headed up by Daniel Marti. I'm not exactly sure to say his last name. He's actually a Go contributor, like an official Go maintainer. Yeah, I was surprised as well. And it is a much more intelligent project that aims to do the same thing, but does it in a much more streamlined and maintainable way. Just to remove all metadata and stuff. So basically, what Garble does is it uses a little-known feature of the Go compiler called toolexec. I actually didn't know about it until I started looking at source code, where basically, so I think, Ben, you're nodding your head. Correct me if I'm just describing this poorly. So basically, when you run Garble, it wraps the Go compiler. So you give it a package, or you give it like a file, a main file to obfuscate, and then what it does is it calls the Go compiler on that file, but passes the path to itself as an argument to a toolexec. So basically, when the Go compiler runs, every time it compiles a package, Garble is called first, almost like a callback, except it's just binaries. And so Garble has some mechanisms to detect if it's being called by the compiler first, but it's not really important. And then what Garble does, it obfuscates packages individually. So it doesn't do what goBFuscate does and renames one identifier and searches everything and then moves on to the next. Its obfuscation is deterministic. So you run it against source code 1, 2, 3 times. By design, the output's always going to be the same. And you can specify a seed so that it won't be that way. But the goal and the hope is that you're not going to get back the plain text symbols without the actual source code. And so because of this, you don't have to worry about searching everything when you rename a symbol, searching all imports, because renaming is deterministic. And so it goes through and strips a bunch of stuff. It strips the Go compiler version. It strips the Go module data if you're using Go modules. It renames a whole bunch of identifiers. It can optionally scramble literals using just, classic obfuscation stuff, and a couple of things it can do as of recently. A couple of the contributors and I are working on actually using it to make Go binaries smaller by changing all line numbers to 1 and removing all file names, because Go uses a variant encoding for the line numbers. So basically, if you have a line number of 65,000 and you have a line number of 1, 1's going to be a lot smaller, especially added up everywhere. So, and another novel thing that I myself worked on is garble can actually hide all of your panics from Go binaries. And the way that works is I actually have some code that when garble gets to compiling the runtime package, I inject a bit of code in there and modify a tiny bit of code, basically saying hey, whenever you're gonna print anything in the runtime package, whether it be a fatal error or a panic, basically just check to see if this Boolean value is true, and if it is, just don't print anything. It's no op. And so we expose what's called a runtime API. So you can optionally call hide fatal errors and pass in true, and then your Go program crashes. No longer will it show you this big stack trace of where everything is going on. And even if you obfuscate your binary and the symbols mean nothing, it can still be helpful to someone reverse engineer your program to kind of see what's going on. Or sometimes maybe you've injected a Go DLL somewhere and you don't want people to know that it's Go. You just want it to think that it's the Windows thing. And if it spits out a giant panic thing, it's that doesn't look normal. So I'm pretty happy with that. I haven't used it yet, but I haven't used it myself on anything like my malware yet, but I'm excited to use it soon.
I'm actually pretty excited about that too, because I think it'll change how I write my code a little bit.
Oh, really?
Yeah, I've been thinking about this since I first heard about this feature, and I've actually been subtly rewriting my implant code to use panic more often. Because now I know it can be hooked and shut up, right? So otherwise you need to kind of have your own logging framework so that you can debug an implant and then have it say nothing at all when it's running in production mode, But I've been writing Go since before they had a debugger, so part of my Go debugging strategy still is print statement based. But it's only been a year and a half since Go's had a debugger, right? It seems like a lot longer.
I think they had it at least back in late 2018 when I started, but I don't know how long it was there before that.
They had those really shitty scripts for GDB. Those were super helpful back in the early days.
Well, now there's the Delve debugger, which is actually a Go layer of abstraction debugger. Before that, you could debug a Go binary in GDB, but it would think it was like a C app more or less. So you wouldn't get a lot of helpful Go metadata.
No, not at all.
You'd be like stepping through the runtime instead of stepping through Go lines.
I got a defensive tool I want to bring up because it's kind of right around that. My buddy wrote a Linux kernel module to debug Go programs and try and get more insight as they were running on Linux.
Really?
And
what's that called?
It's called Go Killer. He ended up finding a memory map that all these Go programs call, and he has it all written down. He was trying to stop GScript specifically, but he ended up just being able to detect and stop any Go executable. It's D. Robertson, cool. And it's called Go Killer. And it reminded me of when you guys were talking about the same runtime being loaded every time. That would be pretty easy thing to kind of signature on.
So it's a kernel module for Linux
sure.
or Linux or Windows.
So Linux LKM loadable kernel module, and then it just detects this one mmap call.
So the other nice thing, there's one nice feature about writing malware in Go. So whenever over the years when I'm considering switching my malware development to a new programming language, I always look for what I call the pi to exe situation, or previously the jar to exe situation, which is pi to exe and jar to exe were ways of just making a Java program into an exe for Windows, or a Python script into an exe for Windows. And fundamentally, all they do is they take a JVM and they stick it with some Java, and then they wrap it up as an exe, or they take some Python and stick it with this loader, and they wrap it up as an exe. And of course, this lets you write great malware because EDR is all signature based. And they're looking for like signatures and binaries, and the only real binary signature when you have this like embedded loader with a script situation is the loader itself. And all you need is one viable, valid program that everybody uses for that loader to be force whitelisted.
Yeah.
And then that means that it will be safe for malware for a decade. So
Yeah.
jar, I don't even remember what used jar to exe, but there was like one program that used jar to exe. So jar to exe had to be whitelisted, and then all malware was jar to exe based all through the late 90s into the early 2000s, right? And then when eventually the one program that used it went away, they added it to the blacklist because it was like, this is nothing but malware, and then it was pi to exe time. And I don't even remember what the legit user for pi to exe was, but for Go, I know what for Go, it's Docker and Terraform. And if you kill all, we learned this talking to Josh Pitts, the developer of Ebola, in the last episode, because when he came out with Ebola, Kaspersky tried to flag it as malware, and they sigged the Go runtime basically, and everyone running Docker just like completely lost their shit because it flagged Docker and it flagged Terraform, and everyone in Cloud World just went completely apeshit.
That's
and now
amazing.
It's whitelisted, right?
I vaguely recall it like killed a bunch of Ethereum things as well. Like it started eating
That makes sense.
Ethereum wallets, which people are probably not very happy about.
That's right. It flagged Ethereum wallets as malware.
Yeah. The original one was in Go, right? Yeah.
Yep. So I think I think Go has reached the pi to exe like stage where people can't actually just ban all Go binaries without serious problems. You know, it's like if you don't use Docker, you're probably using Terraform.
Yeah, just on that, this is something I learned fairly recently, is that PyInstaller uses UPX.
Yep.
So that's the same sort of like vibe as like using UPX on your malware is not as like obvious as it was before PyInstaller was doing all the things, because there's like a bunch of shit that uses PyInstaller now. So
There's
like it's an indicator, but it's not like obviously malicious.
Yep. There are a bunch of programs of valid programs that use UPX. A lot of games use it.
Yeah.
And actually, a lot of the anti-debugging stuff or anti-RE stuff ends up getting whitelisted because of video games. And this is kind of if you think about this really hard, you'll come to the inevitable conclusion that EDR is totally bullshit. But that won't surprise anybody. But I feel like one of the reasons we like doing these kinds of projects is because they sort of demonstrate how futile some of these large business security snake oil products are.
Yeah, like going back to your note just a minute ago, like if you try to do behavioral detection on an interpreter, you're gonna have it's such a hard time. It's an effort in futility, because like that's why if you look at Microsoft with PowerShell, they came out with AMSI, and they have something that scans the scripting language, because doing behavioral detection on PowerShell is like a lost fight.
I would just like to make a note that the donut loader, which I don't know, they don't actually sponsor the podcast, but I definitely give them a lot of free advertising because donut's amazing. But
It is.
the donut loader includes an AMSI bypass as one of its built-in features for .NET payloads.
I think also it does something else too, application control or Windows application control, some other thing that's not super widely used, but also bypasses that, I believe.
Yeah, there's a bunch of stuff in there. So just to wrap up with garble, what does garble leave in there right now?
So right now, this is actually something I was going to run back to. Perfect. Garble does not exported method names, and I think it doesn't garble exported struct fields, but that is ongoing work. And the reason why it doesn't do that, which that's a lot of stuff not garbled, but it's because of Go's use of reflection. And so you can't just, garble everything that's exported, because something could be you're trying to use it reflectively. And this is also actually the same reason why, fun fact, if you or any of your recursive dependencies uses reflection somewhere, the Go linker can't really, its hands are tied when it's eliminating code, because I think I remember reading, and someone correct me if I'm wrong, but I think the rationale is you can kind of like call any function by name just by passing in a string, like, call this. And so the Go loader can't, or the Go compiler can't just say, oh, you import like this library and you only call one function, but these 90 other functions, they could be called potentially. We don't know. So that's a big reason why Go binaries are so big, because it just can't strip out a lot of stuff, because somewhere down the line something uses reflection most of the time, which is sad. But yeah, so garble doesn't export. Oh, sorry, go ahead.
I was going to say one common pattern that triggers reflection without people actually using reflection is when you serialize, or when you marshal or unmarshal a struct with like the JSON marshaller or the YAML marshaller or the PEM encoder or whatever, like all this, when you're marshaling or demarshaling structs, it uses reflection on the exported fields in the struct to determine like what to write out to JSON or whatever, and that gets used by almost every Go program at some point, just to load config files, to load cloud config files, to write files out, or like wire protocol messages, like all this stuff. So but that's a really good point, is that if reflection is used at all, the Go compiler isn't really smart enough to it may not be able to determine all of the possible strings that get passed into reflection. Like it could be reading a string from the network and then going through the reflection library and saying run that named function.
Exactly.
So the compiler can't know at that point. Which actually, I know one of the other things we'd been talking about, or that's come up in discussions with people, is there's starting to be alternate Go compilers also. So one thing we were looking at is TinyGo, and TinyGo only works for like WebAssembly and some embedded chip, but it doesn't work for Windows because it's missing a runtime. But how it handles its other targets is it actually implements like a micro runtime, and then it has like a different Go compiler, and it generates much smaller binaries. And I kind of looked at that because it was based on LLVM, and now with the garble goBfuscate kind of obfuscation, really what you're doing is you're going in and looking for strings. You're trying to scramble the strings that are in the binary. There's another type of obfuscation, which is like control flow obfuscation, where you actually look at the call graph of something and you make procedural transformations to it that don't affect the behavior at all, but make it look like a funhouse mirror in IDA or whatever. It just makes it look like a freaking mess. And there are some really interesting control flow compiler plugins for LLVM and also for GCC. And I was looking at trying to. So TinyGo is interesting because it's based on LLVM, and then there's also GCC Go, which also doesn't target Windows, which is a Go compiler for GCC, and both of those have control flow obfuscation plugins. There's LLVM obfuscator, and then someone ported that to GCC also. But I couldn't match a compiler that generated Windows binaries with one that also supported compiler plugins. So like MinGW doesn't support GCC Go, and it can't really without a bunch of work. And TinyGo doesn't have enough of a Windows runtime to like generate Windows binaries. So I guess what I'm wondering is, have you heard anything about alternate like Go compilers coming down the pipe, or maybe someone's doing like a Windows runtime for TinyGo, or maybe the what are the plans for reducing the Go runtime, if any? Has anyone heard anything? Yeah.
I haven't heard anything. I don't know of any other compilers you meant besides the ones you mentioned. And as far as reducing the runtime, the only thing I know of is there's been a big effort in Go 1.15. I know it's continuing 1.16 to rewrite the linker, modernize the linker, and some of the size, like binary size decreases we got at 1.15. There are some. It's not huge. It's like around 5%, like on average. Was just the linker being more more intelligent about dead code or just eliminating code that shouldn't be there. And I think that's going to continue and Go 1.16. But I haven't heard anything in particular about the runtime itself getting smaller. But the Go linker / compiler should be getting smarter at eliminating code that doesn't need to be there, which is always good. But,
I have one more. Yeah. I have one more kind of stupid question in this topic. Before we change gears, but so before garble or before obfuscate, the one trick for making your Go binary smaller was this. There's an LD flags option to Go that passes flags through to the linker, and if you did LD flags -S-W, it would do something and your binaries come out smaller. And I'm wondering, since you're one of the few people that's actually spent any time kind of reversing Go that I know, and also looking at garble, I'm wondering what's the difference between LD flags -S-W? Like, I don't even really know what that does. What is the difference between that and what garble's doing? And would you use those with each other, or what?
Yeah. So actually, garble is really nice in that when you call it, you just say it kind of functions like the Go compiler. You can say garble build blah, like go build blah, and then it actually passes a couple of compiler flags that you want, such as LD flags -W -S. So you can use them together. They're actually garble by default always uses those options because it strips a ton of unneeded stuff. And what those options are actually doing is that stripping all of the dwarf debug symbols that like delve and stuff use, and that saves a ton of. You can sometimes like have the size of your binaries if you do that easy. That's just basically stripping out all the dwarf info. And garble will also pass trim path, which basically trims all of the paths from the file name of the binary, all the local stuff. So if I'm building a binary out of /home /capnspacehook, and then all the file names in the binary are going to be prefixed with /home /capnspacehook, but with trim paths, it'll just remove that. So binaries can be built deterministically and stuff. So yeah, to answer your question, if you're doing anything with Go malware, you should probably always use TACW, TACS, LD flags. and garble will do that for you. And yeah, it is just stripping dwarf debug info.
Let's move on. So while we're still on the subject of kind of anti-RE and EDR evasion, there's one more project of yours I want to call out, which is Pandora's box. Yeah. So one cool feature of Go is that it has really good support for virtual file systems. And what that means is any place in code where you're using like a file abstraction, you can, that's an interface in Go that you can shim out kind of underneath it and point it at your own implementation of a file system entirely in memory, if you want, or it can be backed by whatever. And I did some early experiments with just sort of having an AES encrypted zip file on disk, and then like decrypting it, unzipping it to memory, using it as a read-write file system, and then when you're done, sort of zipping it up and putting it back. And you went and did like the grown-up version of that, kind of totally built out with some kind of extra features. I'm wondering if you could tell us a little bit about that.
I might tie words up. Pandora's box is basically like you mentioned, an encrypted file system in memory, virtual file system in memory. And so you kind of mentioned that like Go has like interfaces for files and stuff, but actually, sadly, it doesn't yet have interfaces for dealing with files. That's actually a proposal that's having ongoing work done to it, and once that happens, I'll have to rewrite a lot of Pandora's box because a lot of the stuff I had to do manually. But Go has really good support for dealing with files and stuff. Its OS library is great, and basically what Pandora's box is it's all of the OS functions, all the methods on os.file that you know and love if you're using Go, and it all transparently will work in an encrypted file system. So basically, I rewrote some of my an implant I built with the C2 to use Pandora's box instead of OS, like the just writing the file stuff. And literally, I designed it so all you'd have to do is replace OS with github.com/capnspacehook/Pandora's box, and so basically, all the same functions work the same. It just transparently uses it in memory. It's encrypted in memory. And so one thing I added in because sometimes you want to write files on disk, and sometimes you want to move them to and from the virtual file system. So basically, if you prefix any path with VFS:// then Pandora's box will know that you want to do something in the virtual file system. And if any of your paths don't have that prefix, then it'll just use your host file system like normal. And there are methods you can tell Pandora's box, like, I don't care what the path is, like force it to use the host file system or force it to use the virtual file system. But just for ease of use, I added that in. And
that's really slick because bananaphone kind of gives you this layer of abstraction where you can write things to regular system calls, or then you can just sort of shift and write to direct system calls, and then they get bananaphoned. And Pandora's box is this layer of abstraction where you can deal with the regular file system, or you can be dealing with a in-memory encrypted file system, and it's kind of transparent to your code after that point. And I just think that's really slick.
Thank you.
Yeah. Ed, what about memguard? Like, what is it, memguard? Or there's some extra magic in there too, right?
Yeah. So all the encryption, I was going to talk about that. I am not a crypto guy. Math is my strong suit, but I try to use crypto correctly the best I can. I don't claim to understand all of it, but there is a fantastic Go library that if you're doing anything with Go malware, I definitely have to recommend, called memguard, that does a whole lot with encrypting and storing stuff secretly in Go. and I leverage that code to do all the encryption for me. So basically, what happens in Pandora's box? Any of the files that are created, it's stored in a what's called enclave object in the memguard terms. And what that is it's it doesn't use AES, it uses some other symmetric hash. I think it's something similar to like NC or NACL, like secret box type stuff. And it kind of has it's encrypted with a key that's being rotated in memory like every couple seconds or something. It's all done transparently. And whenever a file is accessed, it will then decrypt it to into a what's called locked buffer in memguard terms, and that's a really cool thing. It's actually a portion of memory that memguard mem maps or m maps into memory, dependent on what OS you're on. It's done using syscalls, and it creates kind of like a read-only space of memory, and it creates two guard pages on either side of that are actually no read, no write, no execute. So if anything kind of tries to trigger buffer overflow and read that code, the kernel of your operating system should enforce panic or just just killing your application entirely. So even when your stuff is decrypted in memory, it's still kind of like hidden in this buffer that should be resilient to like buffer overflows and stuff like that. It's pretty cool. It's pretty slick. And like again, I didn't write any of that. I just use it. And so yeah, we'll note disclaimer though, all the file names in the VFS currently are not encrypted. That's something I want to improve going forward, but all the contents of your files are. Again, whenever you read anything, it's decrypted, read, and then re-encrypted. And currently, whenever you read something, the whole file is decrypted. I think in the future, I'd like to improve that. So if you just read, a certain offset or of the file, you could not decrypt the whole thing. I'm not sure how I would do that, but there's some improvements that could be made. But yeah.
Does memguard need C-Go?
No, memguard is pure Go, which is amazing.
That is amazing.
Yeah, definitely check it out. It is a super cool project. I was actually just thinking right now. I guess it could potentially benefit from a fork that uses bananaphone to do mmap stuff. But thinking about it, that's somewhat normal for a process because you're not allocating memory into other processes. You're just allocating memory in your own process. So I don't think this should be too shifty. So that may or may not be an issue.
I also suspect that if I had like SE debug and I used the right algorithm to dump, like if I was walking all of the allocated pages rather than just trying to do a raw buffer from here to there, if I was just like walking each page and dumping each page, I don't think I would trigger the guard page either. But I guess everything's encrypted. Everything's encrypted, right? So I could definitely, like, if I was trying to reverse engineer this, I could definitely dump the memory out. But you'd have to, I guess, find the key and decrypt the blob.
Yeah, you'd have to find the key, decrypt the blob, or you could kind of hook certain functions that like, oh, in this read, it decrypts it and just kind of wait till the program decrypts it for you. Because, at some point, it's got to be decrypted. So this is just it's encryption, but it's really just obfuscation at this point because the key is somewhere else in memory.
Yeah,
but like I said,
that's more or less when Donut does encryption too. It's more or less just obfuscation, like because it writes the key right next to the encrypted payload. So it's more or less just to avoid having a signature. Because you can just have a random key every time, and then your whole thing's random.
Sure. Yeah, I mean, this whole thing was designed so if you want to load up Mimikatz in memory, if something scanning memory, it's not going to see Mimikatz. It's just going to see some encrypted blob,
Well, what I think is really, really cool about this idea also is that if you kind of wrote all your stuff to Pandora's box, that gives you a layer of abstraction that you could later look at using a real secure enclave of some sort. Like if you can get into SGX or into like if you're on Android, maybe you can hide your implant keys in the secure wallet or something like that. But you could if you have that shim in place, when you do get a better enclave to keep your keys in, it gives you an easy way to transition to that. I'm fully expecting SGX malware to be a thing at some point. And so is Intel, by the way. So it's,
be your own future.
yeah. It's just it might be a self-fulfilling prophecy. So it goes.
Have questions or comments about any of the content in this episode, or even vaguely related to anything in this episode? Call the Hacker Helpline at 206-486-6272. Are you a C-Sto whose CEO is trying to tell you how to wire money to the folks who breached your NoSQL database in order to use you as a legal scapegoat? Call the Hacker Helpline at 206-486-NARC. That's 206-486-6272. Or send an audio email to podcast@symbolcrash.com.
All right. Well, moving on a little bit. So we've definitely talked about anti-RE stuff, and we've talked about EDR evasion, but we also have tools for recon and spreading. We need to go over, and then I definitely want to spend some time on C2s before we get to the end, because Golang C2s is like a booming sector right now. So just real quick, so back to C-Sto. So the other tool of yours that we've crossed paths on quite a bit is goWMIexec, which is simultaneously incredibly useful and janky as hell. No offense.
None taken. I would describe it thusly.
Yeah. So it's like do you want to take tell us a little bit about goWMIexec and how that came to be and why it doesn't work every time you run it?
Sure. It is. Hang on. I can read the GitHub about thing because I think that summarizes it good. It's a really stupid reimplementation of invoke with goWMIexec. So I built it by literally looking at how I think it was Checkmander's C# version of invoke SMBexec, which has the WMI stuff in it. I just wrote the Go version of the C# stuff that they were doing, and they had to make a bunch of shortcuts, and writing C# out of PowerShell isn't it's pretty close, but it's not an exact one-to-one map. So there was a bunch of stuff that they had to do to work around the PowerShell, and obviously dealing with WMI stuff in PowerShell is kind of gross. And I think the invoke SMBexec stuff was actually based on the impacket shit as well. So we weren't starting from a good place in terms of neat and understandable code. So it's just the fourth version of this shitty stuff. But it's using DCOM and WMI it's just a Go version of SMB or WMIexec. And the reason that it doesn't work all the time is because there's a lot of just copied and pasted byte arrays in there that haven't been fully defined very well. Trying to define them all from how they were in impacket, and
that sounds like a Microsoft specification.
Yeah,
Yeah, it absolutely is. So there's a lot of different ways to do kind of remote control or management interface stuff for Windows. WMI is one, and then there's there can be there's an HTTP or HTTPS interface to WMI, and you can also make a direct Samba connection, which is one thing that Impacket is definitely the best implementation of all this stuff. The problem is it's in Python. and but it works really good. There's a lot of unique tricks in Impacket. There's a lot of stuff to study. But the one thing we're really missing in Go is an implementation of the DCE RPC message format stuff, which is like one of these old-timey RPC frameworks where you're supposed to like write stubs and then run it through the magic generator that converts your stubs into code. And you can even like, this is technically an open standard that you can read, and you can even look at the source code for their like stub generator and still have no idea what the hell's going on. It is like the most insane, like your brain just rejects it on contact. You know, it's like I've tried to read about DCRPC like so many times, and I'm just like, it could be pouring rain outside, and I'm like, I'd rather go outside right now. You know, like literally anything else at all in the world, I'd rather be doing. But Impacket has a complete like DCE RPC library, so like I think the problem is like underneath WMI is DCE RPC or MSRPC, which is this totally bizarre format for remote messaging. And we also we did a fork of goSMB 2 and got which can actually mount SMB shares. It works really well, and we actually got that working to do. It can connect. We added named pipe support to it, so it can actually connect to like service control and like the named pipes that you can pass MSRPC commands to on Windows. I'll show you. It's not totally working. So we got it up to the point where it can do the transceive calls and write messages to and read responses from the named pipes. But we stalled out because we need to format these messages into DCE RPC. And really the only code we
fucking stupid.
Yeah, and I even I went so far as I ordered some like rare book that was supposed to help. But it does seem very useful. It's called DCE RPC over SMB. But it's from like the 90s basically. Like none of this has changed since the 90s. So at some point we'll get around to doing that, I guess, and that should make goWMIexec really stable, and it should also give us the ability to do more like what Impacket does or what PSExec does, which is actually an SMB connection and then MSRPC directly to a named pipe.
Yeah, I did want to mention Go Netscan, which is a tool I was writing with Lucas Morris or Emperor Cow, who wrote like Crack Lord and like a lot of cool cracking stuff, and then also a lot of SMB work back in the day, and like CIF mapping. But in that we use and there's like a lot to talk about that, but in that we use the SMB library by Stack Titan, which is those dudes that wrote the Black Hat Go book, Tom Steele and Dan Kottman. And that's the most complete Go SMB library I've seen yet, and it's not really complete. It's like half done.
The one we forked was by Hero Cha 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 or something, or Hero Cha Cha. It's called Go-SMB2. And it actually, so how I get the end-to-end, like PSExec thing right now. So what I've been using in my private software stack, anyway, at least for part of it, what I do is I actually use the goSMB2 library. I connect to the host, I mount its $C$ or whatever, or the admin share, whatever. I copy over my executable, and then I do a goWMIexec call to execute that executable until it works.
That's awesome.
Yeah, because like it doesn't work all the time. Because sometimes you can't. It's not fully parsing the messages that come back, and so it works like most of the time. But sometimes you get a message back that's probably like temporarily out of commission or something, but like it doesn't know what's going on. I don't know. But that I actually kind of reverse engineered PSExec a little bit. So before I discovered Impacket, I had a copy of the Microsoft Message Analyzer, and I was just recording using which is an old tool. It's no longer on the web, but it was a tool Microsoft put out that looked at the ETW logs, the event logs, and it would give you a full dump of an SMB conversation. which is now very difficult to do because SMB 3.1 is all encrypted and supports dynamic key renegotiation. So there isn't actually an easy way of getting Wireshark to dump it anymore, for example, which as an attacker is a compelling reason to use it. Because the only tool that dumped it cleanly, Microsoft pulled from the internet back in November. So, you know,
Are there still archival copies that are around?
I mean, I may or may not have one, but
Well, yeah.
I don't know. I'm afraid to put it on my website. Let's put it that way.
Yeah, I mean, Microsoft has teeth.
Well, like the thing that really screwed me up is I was very excitedly telling a Microsoft employee all about this thing I'd gotten working in Go like a week before they pulled it from the internet. So I was like, I had this whole paranoid, like, did I do that? Moment, but you know, it's probably not my fault. I don't know. But anyway, so what does Go Netscan do? Is that like a recon tool?
Yeah, originally I wrote this tool called Go Red Shell, and my idea was like, as we've been talking about, like we have all these tools we love, and we're trying to port them all to pure Go libraries so we can like include them in our monolithic Go malware libraries that we're writing. So I'm like, all right, got CrackMapExec, really nice for just launching like lateral movement commands on the network, getting execution somewhere else. And I was like, I want that in Go. And for my purposes, I was going to use it in a cron job to like check credentials over time, over like long periods of time, like every hour. So I was all about like, you know, getting a nice output and all this nice logging, but I also wanted to get as many protocols as I could in there. So I started like writing this crazy tool, Go Red Shell, and it just like spiraled out of control and it was gross. And then 2 years ago, that guy, Lucas, helped me rewrite it, and it's so nice now. It's like everything implements this scanner interface, so it's like nice little modules you add, and then it's all multi-threaded with like channels, so it just like it whales now. It goes really fast versus like the old implementation was all single-threaded. So it's nice, and it has a nice output. And then like what I've been doing with it is I just like sit on it and I watch all these people that like bring in different protocols. People are like, oh, I got like goVNC now, or you know, this goWMIexec. And I'm like, that's it, and just keep adding them to this shopping cart of a scanner.
Nice. I really, it makes me laugh when people are all the Go malware devs I talk to. They're like, "Oh, it's so nice now. It's all like good. The design is all nice." Or it's like, or they're always refactoring things to make it nice. And just the language "nice" really, it seems like an OCD thing to me. And the funny thing about Plan 9, just to go way the hell back in history, is Plan 9 was like an experiment by like Bell Labs or whatever to just unleash the most OCD pedantic people they could find on redesigning Unix. And they like, so they basically just went through Unix with like ultimate OCD and made Plan 9, where like everything is nice and it's always in the same order, you know, and it's all consistent, you know. And then I've noticed, right? So like Golang is basically Plan 9, you know, the Plan 9 OCD applied to C++, and then all these security people love it, you know? And I kind of wonder if like that's not a coincidence on some level. Like the reason we all got into criticizing other people's stuff is because we're like maybe a little bit pedantic and OCD, you know? And then if you think about like the history of sort of Plan 9, it's kind of like those are like our predecessors. Those are the people that were like us in the 70s, you know? And I don't know. It's just that's just why I think it's so weird that Rob Pike hates hackers.
You keep mentioning Plan 9. All I can think is the Plan 9 bunny. So I never actually used the operating system more than like putting it in a VM at some point.
It always makes me think about Ed Wood. Every time I say Plan 9, I think about somebody snapping a cardboard gravestone in half by accident, and then he's just like, print it! You know? Because it's kind of the opposite of that, right? It's like, no, we have to redo the whole movie, right? That's what the Plan 9 team would do. They'd be like, oh, we have to start over and make it perfect. Anyway, big tangent.
Relate to that.
Anyway, so so one thing we're kind of light on in Go is, although someone pointed me at a project the other day, which was like everyone's been waiting for a port of lasagna, a port of lasagna to go, and then someone pointed me at one the other day. But I'm wondering, and I don't remember the name right now, but I'll dig up the link and include it in the comments. We're gonna have a big comment link section this time
for the audience and myself that don't know what lasagna is.
Lasagna is another excellent Python pen test tool. Basically, it is a collection of all of the local password scraping logic. So it scrapes all of your browser saved. It scrapes all the saved passwords out of your browser. It scrapes your messenger passwords out of config files. It has, I don't know, like 50 different programs that it knows how to scrape passwords for. So obviously it's flagged by every kind of AV in existence. But if you can get it to run, it's like 2 seconds and you have done all of your, due diligence recon in one shot, and you're like, you're off to the races with all of the saved browser passwords usually. So I saw C-Sto, you had a project called Secrets Dump. Is that what does that do?
Yeah, Go secrets dump because you have to prefix all of your Go projects with the word Go.
Is it Go Secrets Dump?
Yeah, Go secrets dump. It's so that is just a reimplementation of Impacket's secrets dump, and that came about because so what it does is it dumps out ntds.dit files really, really fast. Because I don't know if any of you have been experienced using Impacket secrets dump to dump .dit files, but it takes a really long time if they're quite large. And that came about because we were in some crazy ICS system that was using Active Directory to automatically, all of the sensors had AD accounts or something crazy like that. So the .dit had been around for 20 years, and as they added and removed sensors, they would add and remove accounts and shit like that. So it was pretty insane. Anyway, we got on there. We dumped the dit, and it was 50 gigs or something insane. It was extraordinarily large, and trying to use Impacket to dump that out, it legitimately was taking a day or two to pull all the hashes out of that. So I started looking into how it worked, and much like all of the other Impacket stuff, it was built by reverse engineering the Microsoft stuff before there was any public versions of it. So it wasn't particularly optimal. So I just wrote it in Go, and now it's 50 times faster than the Impacket thing. Something that takes 4 hours in Impacket takes 5 minutes in Go secrets dump.
So I'm not as familiar with the dit file dumping. That gives you a way of pivoting. Is that dumping a SAM hive or something?
Yeah, so it's the equivalent of dumping the SAM hive on the domain controller, I guess. So you get all of the hashes for every single user in the domain. It's sort of it's like a persist. I guess you would use it for persistence. The only thing that people really do that for now is password auditing, because that's the only way that you can get hashes out, even though Microsoft doesn't like it.
But you can get creds out of a dit file you can use to pivot.
Yeah. So you get NTLM hashes. You get the most useful hash that you can get out of it is the curb TGT thing, because then you can just craft your own Kerberos tickets.
That is the Kerberos ticket granting ticket for. We can't assume anyone knows anything about Kerberos. That's rule number one about life. Nobody gets Kerberos.
Yeah. So the Impacket stuff is probably more useful if you're going after one specific hash. If you just want to get that hash to be able to do whatever you want on the domain. The Impacket version is better because it does that crazy thing that Delpy, the domain controller impersonation thingy, where it just DC syncs the one hash.
Yeah, DC sync.
Oh yeah.
Yeah. So Go secrets dump doesn't do that. all Go secrets does use well is parsing a .dit file, and it does it very fast, which is, yeah. I basically wrote it in the time that it was taking Impacket to dump like a big dit. So
Yeah,
There you go.
Python is very slow.
I was gonna say you can rewrite Go tools in the time it takes your Python tools to run.
Yeah.
Oof.
It's a pretty good flex right there.
Yeah.
I wanna, if we had time, I wanted to plug a secret searching tool I wrote. It's called Go Red Loot, but it's basically just grep, like grep on crack, right? Like you have file excludes, file includes, word excludes, and then word includes, and then it does this like recursively, and you can say how many depths of recursion you want to go or where to start. But then what it does is it automatically zips everything it finds, and then also encrypts it with a password, and then like puts it wherever you want it. So
Nice.
I use it all the time on pen testing because like it also covers compression and encryption if like you're just trying to like emulate attacker techniques, like for staging prep.
Yeah, totally. Actually, I forgot when we were talking about malware lifecycle stages. There's usually a phase named loot, where you just loot, right? And that's where you grab all the passwords. And I think I was kind of calling it recon, but recon usually means like you look around the network, you try to pivot to other machines. Loot is like you just steal everything that's not nailed down.
To bring it back to hacker,
right?
to bring it back to the hackers movie, it's where you get the garbage file.
The garbage file.
Yeah.
So I actually, while we're on the topic of loot, I wrote a stupid little utility in case you ever pop a cloud instance on AWS. If you look in my GitHub, there's a little utility called MetaLoot with absolutely no documentation. That is a very simple way of dumping the entire metadata service out with no prior knowledge about what it is. So when you're all AWS instances, they're trying to fix this now. So there's some ways of locking this down that may or may not be implemented now. But every AWS instance has a little web server running on localhost, where not really localhost, but it's like
yeah, it's not
what's
local.
the number?
It's like 165 dot something. Like it's
there's
three digits.
There's some 254s in there, right? But I forget what it is. It's in the MetaLoot project. But like there's some IP address that's only accessible from the AWS instance, where if you go to it, it has all of the metadata associated with the instance, including the AWS creds. And there's a slightly different format between a couple of the different instances. And the one tricky thing about it is you can't spider it using like wget, because they don't link to each other in the way normal web pages link to each other. So I just wrote a stupid little Go program that will work around that and spider an arbitrary metadata instance service, dump it all to disk. And I don't encrypt it or anything or zip it up, but you should totally steal that for Red Loot and just do all my work for me, and like maintain my code, because that's the best, really. But no, that's very cool. I'm definitely going to check that out. Maybe I'll send you a PR. No promises.
Yeah, I like that little loot tool for like just the big three operating systems. But honestly, like everything's like pen testing. I find a lot of it's going towards the cloud now and exploiting like cloud infrastructure or like serverless infrastructure. So this is the next iteration of looting, right?
Yeah, totally. Well, like cloud looting.
Yeah,
it's
got
not even that hard.
Got to scrape all those Kubernetes services.
Yeah, you don't have to. Well, with Kubernetes, you just, if you connect to the right port, isn't it like kubi get all secrets or something? It's almost like you just ask it for what you want at this point.
I think there's like a million different like servers at this point.
It's kubi control get all secrets. Yeah. It's either that or get secrets all. It's one of those. Anyway, so awesome. So the only other project I had on my notes sheet is Taskmaster. What is Taskmaster?
So Taskmaster is a wrapper around task scheduler on Windows, and it's specifically a wraparound task scheduler related stuff using COM, everyone's favorite application programming interface for Windows. I actually taught myself the basics of how to what COM is and how to use it when writing Taskmaster. It took me a full mostly 2 days when I was in school, not when I wasn't in classes, whatever, to figure out how to actually instantiate a single COM object. It was way too long, but
You're saying the documentation's gotten better?
I have gotten much better.
I that can't be right. You still have all your hair.
What can I say? I'm young.
I don't think you have fully understood DCOM while you still have all your hair. That doesn't seem
Oh
right.
no, this isn't DCOM. This is just COM. I haven't ventured into DCOM yet. So
all right, okay.
I still have some of my sanity. I'm hanging on by a thread. But
and we don't have any idea what it takes to re-implement DCE RPC because
that's not something I'm planning on doing. But
anyway,
yeah,
sorry. So Taskmaster.
Yeah. So I am luckily enough. There is a library called goOLE. Like C-Sto said, you gotta have the Go prefix in there. And goOLE is a really nice library that has some nice wrappers around Microsoft Win32 COM calls, and it allows you to do some COM stuff extremely easily. Well, I wouldn't say extremely, but a lot easier than if you were to do it yourself. Even still, like I said, it with that wrapper library, it still took me a while to figure out how to do anything in COM. But yeah, Taskmaster just allows you to view all scheduled tasks, create scheduled tasks, modify scheduled tasks. Basically anything you could do with scheduled task interface on the GUI or PowerShell, and a lot more, because there's actually a lot of, they are documented in MSDN, but there's a lot of functions and stuff, things you can do with scheduled tasks that you can only do through COM. And so unless someone has some custom thing written, such as Taskmaster, you can't do it any other way. So I was, for instance, pretty happy to find out for the red team side that all of the metadata in the scheduled task, there's no checks on it. So I would have thought for sure that if there's a whole bunch of scheduled tasks on the system and it's created by Microsoft at this time, and if you want to say, oh yeah, this is my scheduled task called definitely not Mimikatz, and it's by Microsoft, and I created it 15 years from now, and Windows is yeah, cool, that's fine. It's crazy. And yeah, so all the metadata, you can't do that, by the way, without going into COM, because if you unless you want to go and edit the XML that the task scheduler generates, if you want to do it that way, you could do it, but without editing the XML definition of a task, you have to use COM. So the big reason what's that?
Oh, I was just going to ask if what you use this for, as an attacker, is it persistence or what?
Yeah. Honestly, I've mainly been using it for persistence. Yeah, just some simple persistence. I like to when I'm trying to do stuff I've helped a little bit with CCDC style or teaming stuff. I haven't helped with CCDC, but things where students at university doing red blue stuff. I try to have persistence in levels. I mean, I don't always get there, but some easier, some harder. And I try to I was just thinking about the idea was, I want to do some scheduled task stuff, and then I was well, how stealthy can I make scheduled tasks? And so if I'm not calling, I forget what the actual command line thing is, scheduletask.exe or whatever. I'm not calling that. I'm not using PowerShell. I'm not using the GUI with remote desktop. I'm just writing something that's just calling COM. It's a lot stealthier. And then I took it a little bit further and I can edit the metadata, do all this stuff. And then I haven't actually, it's not implemented in Taskmaster, but there is the potential to go ahead and timestamp a bunch of stuff. So I don't know, I just kind of try to immerse myself in task scheduler stuff. like I said, when you create a scheduled task, it exists in at least two locations. There's like stuff in the registry that points to the scheduled task, and there's an XML file that's written on disk. And so if you want to say, oh yeah, this task was created when the system was installed, you have to edit the time on the in the metadata of scheduled task. You have to edit the time. You have to timestamp the time of the XML file on disk, and then you actually have to timestamp the time of the registry keys as well to make them all line up. So I haven't implemented registry timestamping as something I want to do at some point, but timestamping on Windows in general is pretty easy if you do it, not messing with like the MFT and stuff. But I think it's MFT. But yeah, it's you can do some crazy stuff with it because there's actually some there's actually, if you don't know, there's actually a task scheduler action where you can either run a program from a scheduled task, or you can directly instantiate a COM object and pass an argument and run it. So you can do some persistent stuff where you enumerate all scheduled tasks that are instantiating COM objects and running them, and then you can kind of just edit the registry to say, hey, instead of running this one, run mine. So you're not actually editing like anything in the scheduled task stuff itself. You're just editing the registry and just redirecting it. And you can get some nice persistence that way, for example.
Does that mean your implant has to like be a COM object and have a little COM server so that it can be called?
In some cases, yes, but there's a
you can point it at DLL files. So as long as you've got a DLL that will run, if your implant has works in the DLL main function, then using those COM hijacks will work. I used Taskmaster at some point last year against one of our more advanced clients that was sort of like puffing out their chest and being like, haha, we could see everything that you were doing. And I was like, oh, actually, I know Captain Spacehook built a real nice thing for this COM thing. And I think recently XPN put up that blog post about COM hijacking. So I overnight wrote a real janky thing and then brought it to them and was like, hey, can you see this? And they were like, oh, shit, no, we didn't see that. You got us on that one, which is nice for me.
It
wasn't a total disaster.
It's literally like the oldest interface to it's basically cron tab dot like Etsy cron tab. Been around since the 80s.
Oh man, but COM was or DCOM was the original way of doing like stupid Windows owning in the 90s when because there was no protection on anything, and Notepad was a full-on COM object. So you could literally connect to someone else's Notepad instance on their computer because there was no firewall. Just connect to Notepad over the network and then edit any file you wanted to on the disk. That was basically Windows security in about 1995. And that was all DCOM. So Back Orifice, no one remembers Back Orifice, but Cult of the Dead Cow, all that stuff was all DCOM tricks. Well, I don't know. I don't know. It was 100% DCOM tricks, but there was a lot of DCOM.
Yeah.
I think actually I remember reading when I was reading about the history of COM. COM actually originated from OLE, and it's OLE. It's birthed in Microsoft Word and Microsoft Excel. I guess when you were linking Excel spreadsheets in a Word document, OLE was kind of this weird abomination that would allow you to embed the spreadsheet and have them the Excel and Word share code and stuff. But
it's actually a little bit simpler than that. OLE was invented was invented to implement drag and drop.
Mm-hmm.
So they wanted drag and drop to work between two different programs. And that started this whole thing off, right? So someone invented the mouse, right? And then they invented the click. And then a few years later, they invented the drag. And then they were like, oh, we can only drag things around in the same program. And then they were like, okay, well, if we want to drag a picture from Microsoft Word to Microsoft Excel, what kind of thing do we need? And then that's where things went off the rails. They had to. Yeah, so they invented OLE as this object linking and embedding is what it stands for, and that is this like
Yeah.
standard definition of an object so that multiple programs can refer to it. And then decom is like, well, the com and then decom was like a sort of standard object definition that then they added network capabilities to, and it just got horrendously over engineered, as everything did in the 90s.
Because
Now
PDF 1.4 has COM object support, so you should be able to embed whatever COM object PDF.
The new hotness is whatever your technical problem is, just figure out a way that people can do it in JavaScript, and then you can just hire 100 people off the street to beat their heads against it until it works. And so we're totally into like fast, cheap, and out of control land right now. Which you can make an argument that evolution supports this as rather than having monolithic, intelligentsia, like everything's so thought out ahead of time. It's like, no, make 100 bad prototypes, spend no time on them, and see what lives. Right? That's what life does. It should be good enough for code too, right? But in the 90s, they thought they could design everything from the top down if they just thought everything through. But then you end up with like, decom and MSRPC.
You just end up with brontosauruses, they can't live these days.
Like we all had childhood lead poisoning. We can't think about this stuff. This is just, there's too many words and acronyms, and it's confusing.
I got out of that.
I'm reading the wiki page here, and this is wild. OLE came out of DDE, which like you still use in phishing today with like Excel and all of those macros and stuff.
That's right. Yeah. I heard. See, a lot of this is like before my time, but I just like read little bits and pieces. So
it's slightly before my time, almost maybe.
Oh, one quick note though, I do want to add about Taskmaster. I just thought of this actually. It COM, like the task scheduler COM interface does support connecting to remote computers itself. So with just like a couple lines of code, I didn't do any DRPC stuff or like decom stuff because like Windows is actually nice enough to implement it for me. You can just like connect to a remote computer and then just control their scheduled tasks there. So actually, come to think of it, it could be potential add-on for Netscan or something like that, or it could definitely be a lot of movement technique. I mean, the stealthiest editing scheduled tasks remotely, I don't know, wouldn't be my first choice, but it is a choice, and I have tested it does work.
So there's also like, if we were really hacking into things and trying to be super sneaky, then you do this like, I only want to pull one hash thing. But I think for like red teaming and definitely for CCDC, there's an element of just like make people give up,
Yes.
just like, no, just surrender and sign the check, or just surrender and give up, like depending on the context, right? If you're a consultant, you're just like, all I need them to do is sign the check, and then I move on to the next one, right? So you just need, but in CCDC, it's like, there's a PsyOps element to it where, sometimes you just like destroy everything, to just crush their spirit, right? And that's not something you do as a sort of stealthy attacker. And that's kind of like where, it's like, why would you dump one hash when you can dump all of the hashes, And that's where that logic comes in.
Destroy all the servers and hear the lamentations of their sysadmins.
Yeah, I mean, as someone
what is best in life?
As someone who's been on the receiving end of what you just mentioned for CCDC, I can definitely attest to the success of that kind of stuff. Like it's really hard not to be distraught when everything is just coming at you full force nonstop. It's crazy. I definitely it's a lot of fun. But yeah.
Awesome. I think we should definitely spend more time on CCDC on maybe a future episode. But just to kind of wind things down here before everybody's caffeinated beverages wear off. The last subject I saved for last. But this is a big one, and it's there's a lot of moving pieces. But command and control servers implemented in Golang. So earlier this year, there were probably 4, 5, 6 floating around. At the moment, it really looks like Sliver is kind of pulling ahead. It's actually being included in Linux distros as as a repo. Oh yeah.
I know that. That's cool.
They've got more than a dozen project contributors. It definitely still has some bugs, and there's not a lot of documentation. Actually, the one thing we all have in common is that none of our projects have enough documentation. It's kind of it's kind of to the point where it's like we do expect you to read the code a little bit in order to figure out what's going on. But I was thinking maybe if we all get together, we could hire a tech writer. But we could bring it up later. But hey, if anyone's looking for side work or whatever, I should go on Fiverr and search for tech writers. Get some Fiverr documentation.
I don't know, man. I mean, for a lot of projects, GoDocs is just is most of what you need. I mean, in some cases you need good documentation, but if it's just like a simple interface, like GoDocs is mainly what you need. But
yeah, no, GoDocs is pretty good for API docs, but for a lot of these things, there's kind of weird, like, there's weird things that people always run into, like for Donut, people use GoDonut without looking at Donut, and they don't realize that, Donut has a bunch of fields that don't default to 0, so you actually have to set all these struct fields in the config struct, or the code does nothing. It literally just says, oh, you didn't set an instance type, I guess we're done. Right. So I should really write that up in the documentation. Anyway, enough about my own guilt. Back to Golang C2s. So Sliver is so what I've noticed about all these different C2s is like they have some things in common. They have some differences. They have some pros and cons. I know that a lot of people I've implemented, I think, 3 generations of a C2 that gets used. I worked on parts of it. We use it in our training class. And I know that some of the devs of the other Golang C2s are former students in the class. So I have noticed some familiar code in a couple of places. But I've also stolen some tricks back from a lot of these places, so I figure it comes out all right in the end. So my own C2. So I haven't used Sliver that much, although I've definitely taken an interest in some of the code. But my own C2, I use Donut very heavily, and the general idea is that however you get your code to run on someone else's machine, however you get the implant to run, the implant fires up. I use my own RatNet library for network stuff, so you can use whatever network transport you want. I do have a working DNS tunnel. I would point out that Sliver's DNS tunnel does not actually work. Which is an open issue for them, but also if you look at the code, you can see that they're just trying to cram things into individual DNS requests, and you can't actually get a good stateful connection that way. So they're going to get packet loss, they're going to get things back out of order. So for really, really short messages, it'll work, or like one-way messages, it'll work. But I actually relatively recently published my the DNS transport that I did for RatNet, which is I kind of modeled it on Iodine, so it actually does a full tunnel using DNS, which is pretty cool. Anyway, so I use RatNet so I can toggle between network stuff, and it also has some meshing capability, so you can kind of pivot around corners. So if you get your implant running on a network where it can't reach the outside, but it can find another implant, it can route its traffic out that way automatically, which is a pretty neat trick. But then fundamentally, I try and strip everything out of the implant that I possibly can. And I have all of the different functionality implemented as this is in version 3. So in an earlier version, we had more stuff in the implant. We would send it commands, to trigger the different modules that were built into the implant. But where we kind of went now is we actually have the C2 doing more work. The C2 will actually build the modules as separate donut payloads. and then we send the donut payload down to the implant, and the implant just executes it. So all the implant needs is a reflective loader, and we can then do whatever the hell we want in a donut payload. And that's pretty great because donut lets you convert any executable or .NET program to injectable shellcode. So we can use a lot of the regular tools we're used to using, Mimikatz, safety cats, whatever. We can just pick stuff up. You can cram lasagna into py-to-exe and then cram that through donut, and it'll be big. But
yeah, there was the I saw a tweet that they had like a Python interpreter working through C#. So I assume that you could do the same thing in Go.
yeah,
Just send the Python script down.
Well, and then I don't know if it. I wanted to throw it out earlier, but you guys saw Ropnop did his Go CLR, so he got the CLR working in Go, so you can just load .NET bins through that too.
Yeah, I haven't played with that very much, but we could consider like building a .NET loader directly into the implant, maybe using that.
Although yours sounds way more generic and useful, right? Like you're just loading assembly and then shooting it in. Like there you go.
Yeah, but it's been really interesting to me to see all these different C2, because all these C2 developers, we all sort of talk to each other. We're all in the same chat rooms, more or less. And it's really interesting watching how the design is evolving as people bounce ideas off each other and try different things. So one thing that I saw in Sliver that I really liked is they're kind of moving towards having the implant builder as a back-end service. And they've been trying to play with designs. It's like, well, they really compile their implant and they build in all the modules, kind of like what I was doing in the earlier version, and then they try and like run goBfuscate on it that we mentioned to like strip out strings, and so it can take like 20 minutes, to build and obfuscate a thing. So they were like, hey, what if we build these in a back-end service and then we can cache the result? If the settings don't change, we have the pre-built implant. And that's not really the way I'm going with things. But what's been really interesting to me is the discussion around like we have a backend service that builds, we have maybe a separate backend service that obfuscates or something. Maybe we should be thinking of like chained transforms. It's like, so you have more of like a backend service for your C2 that is like asset creation or asset generation. And then maybe there's a relationship between those backend services so you can chain them together. So you could have one do like compiling things and one do like some round of obfuscation or something like that. And I don't think anyone's settled on like the one true design pattern there, but it's been really interesting to look at.
I was going to mention one of the hang-ups with the Sliver server is that the payloads are keyed to the server. So it's like they have to like export some kind of config or something to their build environment, or have like some kind of distributed RPC library, right, where like everything's talking to each other. Really like Go microservice-y.
Yeah, we kind of do the same thing, but I just sort of use RatNet. So like I basically RatNet, you kind of give it a key pair. And so when we generate a thing, when we generate an implant, we basically just save the public key of the implant in the C2, and then we write the public key of the C2 into every implant, and we don't have to worry about very strict pairing. And also the C2 could ignore, it doesn't necessarily need to enforce the public keys, right? It could let any implant talk to it if it wanted to, as long as the implant has the right key for the C2. But yeah, I decided to kind of address that problem not in the application layer, but in the kind of transport layer, because I needed a key pair there anyway, and you just use it for everything. But I'll just so I'm wondering what other C2s you guys have tried or maybe written, if you want to share anything, and what sort of interesting design elements you've seen. but we could start with no one in particular, maybe Andrew.
Sure. So, do you remember how you talked about Plan 9, everyone doing everything like, top-down designing, like everyone super OCD about everything? Yeah, around December, okay, this is a little bit after I'm trying to think of the timeline here. So I found GScript when it came out. Well, I actually discovered it a little bit late, like September, October, November of I guess 2018. Then I started contributing to that, playing with Go a little bit. A year rolls around, and I'm on winter break in college, and I'm like, man, like there's I think Sliver was not public at this point. It was just kind of talked about in some of the channels Ben has mentioned, and I was just kind of like, I'd heard a lot about Cobalt Strike, some other C2 servers, and I'm like, man, like it would be super cool to design one of those and just have it my own. And I have a lot of ideas. And then I interned at FireEye over the summer and played a lot with Cobalt Strike and some other C2s. And I was like, these are really cool, but I can definitely see a lot of areas for improvement. And, I'm a super OCD person when it comes to code, at least. And, I'm like, okay, I spent a couple of months like finishing, through finals or whatever, just like doing school stuff, prepping for CCDC. But I would, through all that, I would kind of mock up a design for my ideal perfect C2 and started writing code summer of 2019. And I call it Fever. And basically it's a C2 built around, the main thing is super highly configurable implants. So I kind of really was inspired by GScript, where you have this a framework where you can just throw a whole bunch of binaries in, and it wraps them all up, and it just executes them how you want. That still is a great idea. So every implant for the Fever C2, and this is private by the way, so you won't find it if you search it. Hopefully not. If you do, please tell me. I don't want it to be out there, but you shouldn't. Every implant has an embedded scripting engine in it, kind of like, we were talking about, like PyDXE, whatever. But the difference is it's not any well-known scripting language, whatever. Currently, it is a kind of shell scripting language written in Go called Elvish. I'm looking to move away from that. But basically, my original idea behind it was, wouldn't it be awesome if an implant could kind of have all these Go versions of like the standard Linux utilities like ls, cat, whatever, have them all be written in Go, so you're not just calling binaries on the system, and throw it in like a shell interpreter on top of it that's also written in Go. So basically you have like reverse shell coming back to you, but you're not actually just running all these binaries. You're just, everything's being done inside the implant itself. That was the original idea. And then I kept going with it. I made implants such that you could embed like a what's it called? Initial task that could run, but it's not just like a particular task of C2. It's not just like it's not just like run this. It's like a full script that would be decrypted and executed by the interpreter built into the implant. And so my goal for all this is just have an incredibly, like I said, configurable implants, and I leverage RatNet for transport stuff. So like the end goal, and I'm not quite there yet, but what I'd like to be able to do in the future is, allow Fever to generate binaries for anything that can be droppers, that can be stagers, that can be implants, that can be, you can configure them to be ransomware stuff, like anything like that. You just, you give it an initial task, you tell it what kind of modules you want to compile into it, if any. Maybe like Ben said, you only want to compile in like a loader, so you can just throw a donut shellcode and load, and maybe you want to make it super small. Maybe you want to embed a whole bunch of files in it to act like a dropper. Maybe you want it to download a couple files and serve once it runs. It can do any of or all of those things, and then leveraging RatNet to be able to switch transports on the fly. Use multiple transports at once, like it's a fantastic library. So Yeah, and as I've gone along, I've run into a lot of, obviously bugs and stuff, and a big focus for me recently has been stability and just stuff like that. So I've gone back and started like doing extensive DevOps unit test stuff, like for all my RPC calls from client server, like the client that you can connect to the C2 server with, and I built in some Prometheus monitoring stuff like that. So like that's been really fun to like kind of learn this DevOps stuff. But yeah, so that's my take on it. And in the future, I actually have plans to write my own scripting language in Go because Elvis just isn't doing it for me. And that will be public. I'm actually planning on. I have a repo actually right now, but I haven't worked on it in a while. But it's called Rose. My goals for that is to be basically kind of like a melding of the simplicity of Go with the expressibility of Python. And it's eventually, when it's done, in who knows how long, like a year or two or something, when I get time, it'll be just some kind of scripting engine implemented as like its own VM. So it'll compile the bytecode, so you can just shove this encrypted bytes down to the implant and have this like super light runtime that'll just be able to run it, whatever. And so for your implants, you'll be able to give it complex tasks like like Dan was saying with his go red, what was it, the go red dump or go red search or go red loot, I think it was.
Red loot.
Yeah,
Red loot.
go red loot. So you could say like like you could emulate that type of thing, like, hey, like search for anything that has like this substring in it, or like walk the file system and backdoor these binaries if the dates are at the dates created at this time, like anything. Like that's my goal for this. So yeah.
I went down a similar tangent at one point. I started writing a goYAC definition for a scripting language that could compile down to a VM, and I was following was the guy's name Thorsten Ball?
Yeah, those books are
Thorsten
great.
Ball.
Yeah.
He wrote 2 books. It's like, I don't remember the titles, but one's like how to do a compiler in Go and how to do a
interpreter Go and compiling Go.
Yeah, that's it. Interpreter Go and compiler in Go. And I was always a compiler geek in school, but man, those are just as good as like the Dragon book or any of the traditional compilers textbooks. But everything's in Go. And he's got code samples for everything. Like the whole thing will work. The one note I'd have is he really makes you do everything by hand. And there is a Go port of YAC called go-YAC. Surprise, surprise. Which is also not very well documented. And if you're not from the previous period in time where everyone used Go and YAC a lot, you won't necessarily know that in order to use goYAC, it's not just a port of YAC, it's also a port of Bison. So you have to look at the original Bison documentation to figure out what you really need to do, not the YAC documentation. So they called the project goYAC, but really it's Go Bison. So and they didn't write any new docs because I guess us Go programmers don't write docs, is what I'm gathering for the most part. That's cool, because if nobody can figure out what it does without reading the code, then you can just leave it on GitHub without worrying about anything, right? Yeah. But
in the first place, how do you expect me to document it?
Oh boy. So but what I really liked about your when I kind of gave up on the VM, I was inspired by there's an anti-cheat thing for gaming called Themida, where they actually did a similar thing, and they implemented 3 different opcode languages that they can switch between, and they have 3 different VMs, and it gives you a place you can just make things very painful. But I kind of pivoted away from that and started looking at
why not just write all implants in malbulge? It sounds just about as easy.
Yeah, right. Or Bufunge.
Yeah, Bufunge.
But I or brainfuck or Smurf. Anyway, totally lost the plot. What was the last thing I just said? Oh, Themida. Yeah, Themida. so it gives you so I was thinking about that, doing something like Thermida for implants, but then I kind of got more interested in hooking into the compiler like a compiler plugin and doing the control flow obfuscation, because kind of the way Garble is hooking into the goTools interface is similar to a compiler plugin for GCC or LLVM, which there are already control flow obfuscators for. And the cool thing about that is if you hook in at the LLVM level, your obfuscator works on any programming language you can compile with LLVM, not just the one thing. So I got kind of more into what would be useful is something that hooked into the goTools interface and did control flow obfuscation. I don't know if that's even possible, but
sure.
that seems. Hey, there you go.
I mean, I haven't done anything, but if you just, you could take the AST as it comes in and just rewrite the AST of the files to just have different control flows. I don't see why it's not possible.
So I feel like maybe taking some of the algorithms out of the LLVM obfuscator project and just porting them into goTools interface is probably where this is going to end up. And then I don't need to finish my my virtual machine implementation, which is great because it only has 2 opcodes right now.
Enter and exit.
No, it doesn't exit.
just enter and continue.
No, it just. I think it can just add things. No, that's not true. I implemented all of the arithmetic functions, and I got a little ways into it before wandering off. I was like, "This is hard. That's shiny," and then I just sort of wandered off. But that was that and the Go implementation of DCE RPC, just the DCE RPC part of Impacket. If I could put a bounty on that, I would give somebody cred or money for doing either that or writing or helping me write documentation for all of my stuff. But I doubt anyone listening to this podcast is unemployed, but you never know. In the event you'd like to inherit some of my homework, shoot us an email at podcast@symbolcrash.com or leave us a message on the hacker helpline at 206-486-6272. That's 286-486-NARC with a C. All right. So back to Golang C2s. We're
I wanted to mention C2.
Do it. Call it out.
Just because I haven't seen, like, I've used a shit ton of C2s, and I haven't really seen this, and it seems so basic and obvious, and I really like it. It's a private C2. 2 of my buddies wrote, Moss and this guy Javi Havuto on Twitter. It's called Stanza. It's like named after a car. But anyway, the reason I really like it is it's a Go agent, and it's a Go web server, and it's a web application that's a multi-user web application. And you control all your agents that connect back, and they're beaconing. And they have multiple transports, and it has some cool features. Like one that I really like on Linux is the processes will change their process name like all the time. Like they just constantly like change their running process name. But the web application for the actual interface, it seems so basic, but like I don't see that, and it's a nice way to do multi-user,
We've been using a web interface for the C2 since the first version. The first version we had looked like Twitter because the implant would like take screenshots and periodically and do keyboard logging, and then it would add things to this web page that were like the screenshots were like the pictures and the keystrokes logged were like underneath it as the text caption, and it was all pretty. It looked like Twitter. No, that was all Virus. But Virus then the next version, so Virus did the web interface for the next version of this too, and it was like we used this for the class one year, and so like as the RatNet nodes would report in to the implant, and the implant could see like how they were connected to each other, and it used I wanted to use D3, but we got lazy, so we used something called Graph Dracula, which is a little JavaScript library to draw a graph. And he had it actually draw a connected graph of all of our implant nodes and how they were connected to each other, and that showed up on the web interface. And then just as a fuck you flex, he had this like supervillain war room hacker rotating globe video that he set as the web background. So it had this like rotating planet that looked all hackery with your all of your implants graphed out in front of it, and then there was a little like terminal shell underneath you could enter the commands in to like have the different implants do different things. It was pretty crazy.
That's amazing.
The only problem is that the rotating planet video was like 400 megabytes because virus did not want to sacrifice any resolution. You know, he was like, oh no. It's got to be high res. You know,
Yeah, it's got to be 4K.
Yeah, it was like 4K.
Really?
But
Were those
But it
keylogs
does-
like was that like UDP keylogs, like that async UDP keylog stuff? Because I've seen people do that and it's like so resilient. Like they just literally keylog and then just shoot them out of the network via UDP, like one direction, not even a command and control. It's just like exfiltrating keylogs.
RatNet is kind of like a messaging middleware. RatNet can use UDP, RatNet can use TLS, RatNet can use DNS, RatNet can use S3 now. There's an S3 transport in the RatNet Transports project, which is up next to the DNS one. That actually
can't
some
you
friends
use
of
like
mine did.
raw radio?
And actually there is packet radio support for that, but it's not you need custom hardware for it. So it's not as I don't know if that's actually up anywhere. But yeah, as a long running side project, you can get like Raspberry Pis and packet radio. What do they call the daughter boards for Pis? You know,
Shields.
Shields. Thank you. You can get a packet radio shield for it, and then of course you can run RatNet on there and talk packet radio. And the one trick with that is if you want to communicate on ham bands, you need to use no crypto. Amateur radio allows no crypto. That's actually an international rule. That's not just the U.S.
Oh, really?
So as a result, we did implement a null cipher suite for RatNet, which basically uses no crypto. So you can run your RatNet legally over ham radio. But then the moment you're not worried about the FCC anymore, you can just flip a switch and turn the crypto back on by switching to the ECC cipher suite from the null cipher suite.
You know, in the coming apocalypse, yeah.
What coming?
Fair.
Sometime later in the current apocalypse. But no. So that's pretty fun. So yeah, a lot of that stuff's not published, but it wasn't. There's not a lot of missing code if you want to do it yourself. And I do support people who are building that stuff out. So hopefully we will get some published hardware, some open hardware, and some open software up. Although it doesn't require any special hardware if you get a packet, it's just a regular packet radio shield. Yeah, so fun stuff. Anyway, have you played with what C2 do you use, C-Sto?
I'm a big fan of Sliver at the moment. I did write a C2 like 2 years ago because I needed something to work with DNS, and obviously Sliver doesn't really work with DNS at the moment, or it does, but not very well. So I go back to that whenever I need like something really shitty and janky to work with DNS. But I just wanted to go back to the web interface thing because I know that you mentioned that the project that had the web interface wasn't public. There is another C2 that's come up recently, Deimos, DEIMOS C2. That has a Vue.js web interface for its thing. So that's like an open source one for if you want to go and steal the way that they do stuff to make it easier for you to do. You don't have to hack into someone's private project anymore. You can just do the thing.
Does not have a web interface?
No, Sliver's got an interface that's meant to be useful for people that are used to Metasploit, which is not super good. Like you do have, it has the concept of having like multiple people connecting to it, and it's like got a client server. You could like download a client to do the thing.
Because the one thing that everybody says about Metasploit is that the interface is so usable.
Yeah.
Right.
Yeah, it's a weird decision to me, but I mean, it seems to work pretty well. To be fair.
Oh no, I gather that it works pretty well, and that it's definitely gaining popularity very quickly. But yeah, I haven't actually tried Sliver myself. So how do you you don't if they don't have a web interface, how do you interface with it on the C2 side?
The idea is that you have like a Sliver server, and then you can either like use a terminal directly with it, like you would with Metasploit, like just like run the server in your terminal and then like interact with the output that way, or you can have it in headless and multiplayer mode, where you generate a agent configuration which has like a mutual TLS thing in it, and it opens the server opens a port that that a client can connect to, and then like it's like a client that runs on your system that has like this crazy RPC thing that talks to the server. It's kind of cool, and actually there is a fork that I don't think is up to date on the Sliver. I think it actually might be a branch on the Sliver thing that Moloch was working on. There's like an Electron interface for it, which is like a very cool idea, but obviously requires a bit of maintenance. So
Yeah, no, but I think that'll be really awesome. You know, a nice web interface really helps you feel like the supervillain you are. You know,
yes, absolutely.
An
you
Electron
need something you can
interface
blow
will,
up on a wall.
the Electron interface lets that 400 megabyte spinning globe be local. You know.
Yes.
Well,
Yes.
that you know that makes it worthwhile. It makes it worth the 400 megs. You know, because you blow it way up. You can really see the resolution.
The 400 meg file is somehow going to turn into eating up 4 gigs of RAM. So, yay.
Well, no, it was really funny in the class because it was like, why does your C2 take so long to load? Oh, because like it would take like a minute or two for the web page to come up, and then it would just be this giant rotating thing all at once. But yeah, just weird. You know how viruses with weird flexes. That's also like that whole C2. The whole point of the C2 is weird flexes, really. So
Weird
it has
flex,
like,
but okay. The C2.
yeah, exactly. Well, his code name for everything is maximum effort. So, anyway,
Yeah, oh, sorry. I have a friend who offered and did some work on a web interface for my C2, actually, Fever, but it just got so time consuming when I would update the API, or I tried to do like, make some, and I actually was talking to Moloch about this on the in this Golang Slack. One of the main reasons his Electron client fork thing isn't, like, the branch isn't up to date is because when he switched his RPC backend, like middleware, from his own custom stuff to gRPC, which he uses now, he refactored everything to use gRPC. I believe he couldn't get TLS stuff to line up and work with Electron that works fine with gRPC and everything else. And that's the kind of stuff I've been running into with my friend, because I was using gRPC, and for gRPC to work with JavaScript, it's a whole song and dance. It doesn't just work. You have to use like web or gRPC web and stuff, and it's just a big thing. And so like I have this really secure, like, like communications between like my clients, my servers, like kind of how Sliver works. But then it's like, oh, we want to have the web to work, and I had to like consider redesigning part of my API just so a web client could be introduced, and potentially I was like, that's, I don't know if that's worth it for me personally. So, but I don't know. I'm like, I don't want to do JavaScript. I don't know JavaScript. I hate JavaScript. Like, I refuse to write it. So if you want to, sure. But if I have to rewrite my server for your web JavaScript stuff to work, I'm not doing that. But this isn't something that all those kinds of people are using.
Actually, like your C2 design with Elvish. So Elvish is really similar to Bash, basically. And then your idea of having the modules you can add in that implement like the PS command to list processes or other sort of parts of the POSIX, the usual POSIX system. Like, it's almost like I keep thinking that would be really cool as like another kind of orchestration system. You know, it's kind of like bring
Yeah.
your own land. It's like bring your own land, but it's like if you enabled all of the modules, you're basically building a giant static binary that implements like most of the POSIX operating system, except except in pure Go, right?
Mhm.
So you can
So it runs
drop
everywhere.
it runs everywhere, and it might be monstrous, but I'm kind of like, you know, Terraform is not that. Terraform is like a thing, and Ansible's a thing, and there's a million orchestration systems, and they're all kind of crap. But it would be really funny if you could just like write Bash scripts that then went out and ran on like multiple machines, and maybe you could like pipe things from machine to machine or something like that.
Yeah.
And I just thought it was a really neat idea. I just worried that it's leaving a lot of stuff in there that could be SIG'd, you know?
Yeah, I mean, oh, so sorry.
But
Go ahead.
well, then I was saying, but maybe, and that, so I can see how you went from that to garble, right? Because then you're like, oh, all I need to do is like remove all the stuff that can be SIG'd, and then I'm kind of fine. But I kind of like punched out of that to I just have a really minimal implant, and I just reflectively load everything. You know, but the price I pay for that is giant freaking binaries. So I keep asking everybody about like reducing the runtime. Like, hey, so we're gonna reduce the runtime, eh? Yeah.
Please, tell me more.
Hey, well, please think more about reducing the runtime.
Yeah.
Well,
Yeah,
well
honestly,
surely,
though. Oh, sorry. Go ahead.
surely now that 1.15 has like proper position independent stuff, you can just use like a slim C loader to get your to stage your 1 megabyte Go runtime that then calls everything that you need it to do. Like you only need to slam the shellcode into memory to be able to get the shit that you need, right?
Well, so Go doesn't really give us a simple way of reusing one runtime because
Yeah.
it's all statically compiled against the runtime in individual blobs. So like there isn't really a way to like make one runtime work again. I mean, they're probably like theoretically there's no problem with it. It's just that like Go didn't want us to do that, so they didn't give us a way of doing that.
Yeah, it's pretty heavily built on static linking, and so there's no real shared.
There is a really cool project called GoLoader that was depreciated. It's not being maintained anymore, but there's a fork that is being maintained. The guy is some Chinese dude that's brilliant. Like literally, like the day after 1.15 got released, like dropped. He had it. Apparently, I haven't tested it, but he has stuff like his tests working with 1.15. Basically, it solves that kind of problem where, like Ben was saying, if you take like a Go executable and another Go executable, and you try to load one Go executable on the other, the runtimes will conflict, and just stuff doesn't work. So what Go Loader does is you have one main Go program, and you compile Go object files, which are way smaller than Go binaries because the runtime isn't there. It's just like only the instructions for the functions and stuff. And then it actually kind of like reuses code from internal Go like loader and a linker and stuff, and basically like dynamically links the code in, like loads it in, and so you can execute it. It's really experimental, and it's not super stable. I haven't tested extensively, but as I've been heavily diving headfirst into the Go object code and stuff in my work with Garble, I've been taking a little bit of look at Go Loader, and now I can kind of make sense of what it's doing, and it's definitely very very promising, I think, for the future. But yeah.
Yeah, so one idea would be to reuse the runtime, or possibly reduce the runtime. I heard someone say there's a move they could make to just all the things that are in the runtime could basically be treated like regular Go code and only compiled in if they were required by the linker.
That would be optimal. I don't know why they don't do that.
I've been told that they don't do that because they don't like hackers.
I would imagine that standard libraries are so usually interdependent as well. So like running down that reference tree is going to be just painful.
Yeah, you might end up not actually reducing the size of the runtime, because of like if you're forced to include everything you might possibly need because reflection, that might end up sucking in like 80% of it right there. But it's definitely something to keep an eye on in the future.
Being able to manually blacklist might be interesting. Like if you could just
I wish there was a way to do that, like say like, hey, this does not get used. Please do not include this in my code.
Like pragma ignore.
Yeah. And then what I find is that I'm usually horribly wrong about it not actually being used.
Yeah. You know what Sliver's done a lot is they've vendored their dependencies like specifically and modified them so that, like they only have the necessary stuff. So that way they keep their binaries as slim as possible. So like, they'll take some code that like enumerates processes of Windows and Linux and then or some library, and they'll strip out only the stuff they don't need. And so then like, when the Go compiler's like, well, let's take it all because we don't know if it's going to be used or not. Like it's this giant library and they call one function. They're like, nah, we'll just only, only have this one function be kept. So the Go compiler can only take that one function. So, but that's a lot of maintenance and overhead.
All right. I cannot thank you guys enough for joining me on this round the world call here. This has been really, really interesting. I think we've done a really good job of sort of summarizing what's going on in the world of Go malware right now, kind of what the current problems are, what people are looking to do in the future, and what works and doesn't work right now. This has just been like really, I've been talking to you guys online for so long. It's really been interesting to talk to you with voice and video for the first time. I am kind of so the links section for this episode is going to be insane. But just to make matters worse, for kind of closing thoughts, are there any Go offensive packages that you can think of that we haven't brought up already in this episode? Like what else? What did we miss?
So all of the web stuff, probably, like like all of the bounty hunting web dudes. There's that Go project FFUF, fuzz faster you fool, and that's like for a little while, GoBuster was like the fastest version of Derb, and then I wrote Recurse Buster, and then FFUF was written to like fuzz things, but now FFUF is like the de facto web fuzzing thing for bounty hunters at the moment, and that's all Go. I think there was another web thing that's completely gone out of my mind, but I'll link it if I can remember it.
I wanted to plug a repo we have on the Binject group. It's I think it's like Awesome Go Security or Go Awesome Security, and we just added a new package maintainer. So like he's going to be adding packages, and then like I'll make sure to add everything we talk about in this show. You know what I mean? And then it's just like a good central location if people have packages they want to like bring to other people's attentions. Like just pull request it and we'll add it.
Yeah, that is. I'm afraid our link section is going to look a lot like the Go Awesome Security list. But there is definitely a lot of stuff on there already. So that's a valuable resource for sure. Anything else?
I just had I was just going to say I had a quick look at my stars, which was probably not a good thing, but it reminded me of the Relic project that we ran across, which is not necessarily not necessarily offensive, but it's like automatically signs executables of every type, which is very cool and saved me a lot of time.
That's right. I forgot. Yeah. Oh, that thing's amazing. I remember discovering that the first time, and Yeah, it knows how to sign like everything. And of
It's
course,
written in Go?
yeah.
Yes.
And of
Ooh.
course we're going to use that offensively.
Oh, yeah.
But there are also other uses for it, I would imagine. Like,
Yeah, like
you know,
I don't know. It's all offensive in my head, actually.
yeah. If I'm pen testing an environment that and I want to steal their signing keys, and I'm going to use Relic, but they could also be using Relic to sign the things in the first place.
Yeah,
So,
I guess. Yeah, like
you know,
a secure compilation server or something.
it's you know, it works both ways. Yeah, Relic. Oh yeah, Relic is a really good one. Boy, what was anyone else? Andrew, you had one?
Yeah, I have two things, or two main repos in it. There's one, SGN, like I don't know how to say it, the SOG, whatever, the whole like encoder and MSFNM Metasploit, like the Chinese like name or Japanese name thing that like did the crazy encoding stuff, the Shikakita Gane, I totally butchered that encoder. Someone rewrote that and re-implemented that in Go, and yeah, it's really cool. And just something like a shellcode obfuscator. And yeah, I actually just submitted a PR for him the other day because his Docker it uses Capstone and Keystone. It's really hard to get working yourself. He just put a Docker container out for it, but it was like some 1 GB behemoth, so I slimmed it down to just statically include the Go bin the other day, so it's just 6 megs. It's much smaller. But yeah, great repo. And then the other one would be Satellite. It's like a payload server. Yeah, it's a payload server for malware, so you can filter by like authorized agents. You can filter by time, like, oh, your payload's only active for this time. You can filter by you can manually take stuff up or down. You can filter by JAW3 signatures, which I think is super cool. So like, if you try to curl the server and you have everything right, like your post like requests are all right, you have like right user agents, you have all the stuff right, but like if you're doing it from the wrong tool, it'll just like say no. So it's pretty dope.
That's amazing.
Yeah.
I was just being faced with having to write all that myself. Basically, so if people are listening along, like this, the malware delivery server, like a common trick, for example, is maybe it's delivering the second stage malware stuff to the dropper. So a common trick is the first request for a payload, it'll let you download it, but after a period of time it'll stop, or maybe the second request it doesn't even, like, if you make the same web request again, it won't give you anything. And the idea behind that is to prevent like once the implant's been detected and people reverse it to get the URLs out, or maybe they see in the net logs what network requests it made, maybe you deleted or fucked up the original payload on disk or didn't even save it. So someone reverse engineering might try to go back to the server. So Satellite sounds like something I'll be using in the future for sure. Because that's like, you just said some stuff I hadn't heard before. That's a really neat trick. Anyone else? Wow, I'm on a roll here. Like, is that it? Going once?
Oh, I guess if you're interested in JAW3 stuff, the same guy came out with a library called JAW3 Transport that actually allows you to, from your malware, kind of you kind of throw in a JAW3 signature or a JAW3, I think a signature, and it basically tells your malware to send out traffic using that JAW3 signature, so you can kind of like try to masquerade as one something, which is pretty cool.
That is really awesome. Actually.
Yeah, I think it's called JAW3 Transport, and yeah, they kind of, if I remember correctly, they have to like have some internal fork of like the Go TLS stuff because do some stuff behind the scenes, like that TLS doesn't expose because the Go people are like, you don't need this, but okay, maybe I want to say I support these insecure cipher suites because I want to look like this person, but yeah.
I remembered the other thing that I used is Pad Oracle by Swiley7, another Perth guy. It's like a framework for exploiting padding oracles, because you come across those occasionally, and it makes it easier to because there's that Perl version, like Pad Oracle, actual Pad Buster or something like that. Anyway, trying to work with the Perl thing was not exactly pleasant. So yeah, he's got a padding oracle framework thing that you can plug in the requests that you need to do the thing, and it'll exploit padding oracles for you. It's pretty nice.
So for the record, I'll throw it in too. There are a few Go wrappers for Capstone that I have played with, including Gapstone is one. I think there was one called Go Capstone at one point. They do require C-Go though.
Yeah.
So that is I usually try and avoid C-Go because it makes building things really painful. You have to have a compiler set up, a native compiler set up right on all platforms, which is no big deal for Linux or OS X, but it's annoying for Windows. But I have played around with it, and you absolutely can get Capstone decompiling things for all architectures in Go pretty easily. It's just that the compilation can be a bit of a pain in the ass. Although I'm looking at this project now, and it does appear that they have minimized the C-Go usage a bit. So this is probably worth. Theoretically, they could have ported. I guess you can port all your C-Go stuff into Go assembly, huh? But no, I'm not. I think all of this is still just wrapping the Capstone library rather than re-implementing everything.
Yeah, from what I understand.
Yeah. Which makes a lot of sense, but I was looking at it would be really, really awesome. You could get into doing some really, really weird stuff with implants, right? So we have this Go library to parse binaries and put them back together that we've all, most of us have been working. Actually, yeah, basically everyone in the call has done some work on it actually at this point, which is binge action. So we can take the binaries apart and we can put them back together. But man, if you could decompile functions in them and then insert your you could have logic to find places in the middle of functions that it was safe to make a logical insertion and just drop your shellcode there. And there's a requirement with donut payloads that they're all built as position independent code anyway. In fact, they have to be position independent executables or donut doesn't work. Because in order to keep its algorithm simple, it's relying on everything being position independent and relocations being present and stuff like that. But if you were injecting into a position independent code, it's really easy to move it around. So you could move two parts apart, correct the references after that point easily, and just drop your shellcode in the middle. And that would be most of the injection methods we're doing now, we're hooking the entry point and putting the shellcode there because it's easy, right? We're pointing the entry point somewhere else. It runs through our shellcode. Then we have the shellcode jump to the original entry point at the end or start a new thread or whatever, right? But that's also really easy to detect. If you could start taking apart functions in the middle and doing stuff, that would just be really, really annoying. The file size would still change and stuff like that, but unfortunately, having any C-Go requirements in the implant is a manageability nightmare. So I've more or less steered clear of that. Sorry, bit of a tangent, ramble. So thank you guys again for being here. And remember, hacking is not just a crime, it's a survival trait.